those who were here last time in the Unreal 5 development stuff, we were working on AI behavior trees in Unreal 5. And doing so, we made our own little thing that moved in like a free roam style randomly. Now we're going to be getting a little bit more advanced into the behavior trees and actually set up through a series of YouTube videos, set up different systems for an AI system. So like a perception system, decorators, hearing perception, patrol path, stuff like that, which is pretty universal for the AI stuff in games, but especially for the AI behavior trees and what you can do with them. You can expand upon that in a different way that not most engines can do so. So that's something I'm really excited to get into. Yes, here we go.
Hello and welcome to a refreshed, revamped series using Unreal Engine 5 in AI. In this series we'll be covering everything to do with AI in the AI systems in Unreal Engine. In this first episode we're going to start off the basics as setting up an AI character, including how to do their animation using the current new UE5 mannequins. So let's get started.
Which is pretty big.
So we're going to start.
Now, third person, he's doing it in third person scene, so I wanted to create this as we go, so we're going to do that right now in third person.
Start off by creating our character class. Now in our characters folder, which is part of the third person template, you can go in here and create another folder.
He's doing it in here? Oh, okay. I'm going to do it in his way, and then in the future, because I don't know exactly how the trees and AI trees would be best set up folder structure wise for like video games and everything. So I'll just follow with this, and then I'll start like doing the folder stuff later. Adjustments. But this will be AI what?
AI.
Oh, just AI. Right. Nice and simple. Starting to get in the habit of setting color. AI. Just behavior trees. Like that.
And in here we're going to create a new blueprint class and choose a new character class. This is going to be our NPC class. So BP NPC. Now alongside that we also need to add in the AI controller. So go into blueprint class again.
Whoops, I brought this up. Oh, and we're probably going to get into it, so I'll just do that. So AI controller, so blueprint class, all classes.
Search for all classes, and we're going to search for the AI controller. The AI controller is what is going to be controlling our AI character around.
Okay, so not controller, AI controller.
This, I'm going to call it AI or NPC. Oops.
AI underscore NPC.
Next thing we're going to do is we're going to go into our BP NPC and open up our character and set her up to use the mannequin mesh component. On the right hand side we're going to choose animation skeletal mesh here and choose the SKM Mani. Bring that down into the capsule and turn it around, face the right way. This mannequin does come with a animation blueprint, which you can find here, APB Mani. However, there's an issue with this one, in that this animation blueprint does use something that requires player input. So if you try to make anything like AI use it, it won't work. So we have to edit our APB Mani to make it work for our player character and via AI. I'm going to click on my browse icon to get to the APB Mani blueprint here. This only applies if you're using this mannequin's animation blueprint. If you're using your own one, totally up to you. You can achieve that. So the culprit for that you'll find in here is down in this section here.
Okay, so we're actually... Okay. Hold up, give me a second. Load.
State animation in then 1 is just get current acceleration. Now, as you can see from the tooltip, this requires input from the movement component, but a player input.
Which is our movement
component. We don't necessarily have player input because this could be for AI as well. So there's a way around this. We can either skip this entirely and just make this work, which should move, or if we also want to take that into account as well, is we want to do a check to see if the pawn is player controlled. So let's move that down here. Right click and do try get pawn owner. And then
get pawn owner.
Do player controlled.
Player controlled.
Player controlled. We're using this branch here. So it should move. I'm going to take this down and do select.
Select.
So,
okay.
The index is going to be is player controlled. It's true. We're going to be using the stuff that was here previously. If it's false, we're only going to be using the ground speed. False will go to there. And that'll fix that for us to work for both the player and for AI.
Nice.
So go back
Easy.
to that NPC blueprint and you should see it should work just fine. Now if you go to class defaults, you're going to see a section for AI controller. In here you've got two options to need a tweak.
Wait, where? Oh, pawn. Where is that? I don't know where it's at, so I always search it up. I'm just gonna search it. Pawn. Okay.
You can change. You've got AI controller class. So this is the by default set to the default AI controller class that's been given in Unreal.
Yes.
We're going to change this to our custom one we made. AI
NPC.
Then the other option you may want to change is this auto process AI. Depending on what your setup is, you may require your AI to be placed in the wild and be processed straight away. Maybe you want them to be processed only when they've been spawned into the world, or both maybe, or disabled entirely as well. So there's a few options you can do there. We'll keep it as placed in wild for now, but just so you know, that's a thing.
That's good to know.
We're done here. We're going to compile and save this, and we're going to close that. The other thing we're going to need in our map is a navigational mesh. Now, nav meshes are found in your add option menu. Go down to volumes, and it's right at the top. Nav mesh bounds. I've already added it to the level and stretched it across the whole entire level. And just preview it, you hit the P key, you'll see that green nav mesh indicating where the NPC could go. The dark green outlines are borders, meaning that it cannot cross the border unless connected by a navlink proxy or by another navigational mesh.
Good to know.
As a reminder, toggle that off and on with the P key.
Interesting.
Okay, so
they could get stuck up here.
AI character itself, we're going to drag it into the scene. But now we need to give it some behavior to run around. Now we're going to do something very basic. We're going to make it just follow the player character. So I'm going to go to my content drawer, open up the character here, and on begin play,
NPC.
We're going to do AI move to.
Wait, just making sure. So he's in BP NPC. Okay, so AI move to.
And do AI move to. This requires a pawn reference, as well as itself.
Okay.
And the target actor we're going to give it is the get player character.
Get player character.
That is it. I'll save. And I'll push play now. Now you can see.
Oh, it's already automatic like that. Okay, yeah. Oh,
So
but that's nice though if you want to use that. Oh, but it
AI
stops.
We want to make sure they can turn properly.
It doesn't loop.
When you first create a character, you'll find the turning looks a bit weird. It looks very abrupt, very strange. So what we're going to do is we're going to fix that.
Okay.
We're just going to open up our NPC. And you go to class defaults, and on the right hand side you'll see an option saying use controller rotation yaw.
Use control. He's in pawn still. Oh. Pawn. Use control. Okay, so here it is. Use controller rotation, y'all.
You want to turn this off.
Okay.
You mostly only want this on when you're doing first person controls, as you want the control rotation to be manipulated by the character movement component. So speaking of which, click on your character movement component and then scroll down on the right hand side until you find the rotation settings.
Oh.
They are.
That's convenient that it's all closed. I like this. Rotation settings? So that's in character movement. Rotation settings, okay.
And we're going to tick use controller desired rotation.
Okay.
Whilst I'm here, I'm also going to tell it to go a bit slower.
So we're going to
Find
character
max walk speed, turn down
movement.
to like speed 50.
Max. Okay, so we got walk speed, or max walk speed, crouch. So this would be max 350 centimeters a second.
So back on those rotation settings, you will find there's two tick boxes. Use controller desired rotation and orient rotation to movement.
Yes.
These basically mean that the controller desired rotation is the controller wants it to go in a particular way, therefore it will turn the whole character model around to match that direction. Whereas character movement, orient rotation to movement, means if the character is moving a certain direction, it will look in the direction that it's currently moving in. So your camera could be facing one way, for example, and your character could be running another. But for this, for AI, we want it to use controller desired rotation. The rotation rate just means it can turn 360 degrees in 1 second. So if you want it to turn slower, make it lower. If you want it to turn quicker, make it higher.
Okay.
Okay, now if I push play, you can see him now coming after us.
Much slower. Awesome.
And that brings us to the end of part 1.
Okay.
Now we've got a basic character setup, we're going to start looking at the behavior tree system. So in the next episode, we're going to go through the behavior tree, explaining the different functions it has and how we can use it to move the character around the space. You can watch that next episode right now over on patreon.com/Ryan Laley, as well as many other videos too from just $1 a month. Massive thank you to all my patrons and
shouts out, shout out.
Support. Please make sure you subscribe to the channel, and I'll see you all next time. Bye everyone.
100%. Shout out. There we go. Because I want to... I'm not going to fully watch that end. We'll be watching this. So we're going to the second part, the behavior tree, because I was just getting the character set up. There we go.
Hello and welcome to part 2 of our UE5 AI tutorial series. In the last part, we set up our character and the basic blueprints that we need for that character. And in this episode, we're going to talk about the behavior tree, explain how it works and the different functions it can use. So let's get started and taking a look.
Yeah, let's do it.
So for AI to actually take advantage of all the behavioral systems we could apply to it, we really want to make use of the behavior tree system. So rather than having our character using AI move 2 in their character class, we're going to delete this and just put in a behavior tree instead. This allows it to have decision making done by its AI and decide on what it wants to do.
Let's do it.
So let's create our first behavior tree. We're going to right click, go to AI or artificial intelligence and choose behavior tree.
Behavior tree.
First one BT underscore NPC. So behavior tree for NPC.
BT underscore.
Now you could make multiple behavior trees for different types of behavior, which we'll go through later on. But for now, we just need this one.
Okay.
Now, alongside a behavior tree, we also need a blackboard. The blackboard is a tool that allows our tasks inside of our behavior tree to communicate with one another. So to create one, we go to the AI and choose blackboard. And we're going to call this one BB underscore NPC. Okay, now when you first make your blackboard and your behavior tree, you first want to open up the behavior tree.
Okay.
And you just want to confirm that your blackboard asset has been set correctly over here on the right. This behavior tree setting.
Okay.
If it doesn't appear here, just choose it from the drop down. But if there's only one in the whole entire project, then it usually assigns the correct one.
Didn't for me, but I had to set it. That's okay.
You can toggle back
because it was saved.
to and from your blackboard, over here in the top right by changing this option here.
Yeah, I love that so much.
So a behavior tree starts off with a route, and it's a top-down mechanic, and that means that it's going to start the route and then go down and like a flow chart down into the next node, the next node, the next node.
Yes.
So the different nodes that start off with are composites. You've got selector, you've got sequence, and you've got simple parallel.
Okay. Are we going to use these?
Is going to have a series of tasks attached to it. If the first task is successful, it will do the next task in the row.
Yes.
If that's successful, then it'll do the next one, and so on and so forth. However, if one of those tasks fail, then the whole sequence stops and it's considered a foul.
Right.
Now the inverse of that is a selector. Selector again will pick the first one on the left. If it succeeds, then it will not carry on at all. It will stop and consider the whole thing a success.
I see.
If it fails, then it's going to go back up to selector. Then it will choose the next one in line. and so on and so forth until they've all been used up. If they've all been used up and still no success, then the whole selector will fail.
Okay.
Where simple parallel is different, it has two drop downs here. The first one, the purple one, is a single task that you can add to it.
Okay.
And the next one could be anything you like. It could be another behavior tree, it could be selectors, sequences, another simple parallel, whatever you want. And what it'll do is it'll loop whatever's attached to this grey part whilst it is completing the purple part.
Yes.
Well, today we only need to write out
complete.
the sequence
Okay.
and selector, so I'm going to get rid of the simple parallel and just have this set up. This is the typical setup that you normally have with behavior trees at the start, and then they kind of evolve from there, but this is usually a good starting point to do.
Yes.
So for our first task, we're going to make the character run to a random location in the map. Now for that, we're going to create our own custom task. So up top, you'll see new task as a button. Click on this. When you do, it'll ask you to name it and save a location. I'm going to create a new folder here called tasks.
Tasks. Okay.
And the name of this one is going to be BT task move random location.
Random location.
And it'll open it up. So a task consists of a number of functions, and you'll see them over here in the override. You've got abort, execute, and tick. Tick you should probably know about already. Happens on the tick. Execute is basically the begin play of this task node, so it's the first one gets called when it starts up.
Okay.
And the abort basically is when it's cancelled or aborted in any kind of shape or form. So we're going to choose the execute AI version. The AI version and the other version differ in that with the regular version, you don't get the controller passed through. Okay.
I see.
So a little bit more information comes through in this one.
That's good to know.
Okay, so we're going to do a random location.
Wait, why did that go off?
And the best way to do random locations when you're working with AI in particular is the node of get random point in reachable radius. Or, get random reachable point in radius. There we go.
Okay.
So the difference between the reachable one and the navigable one.
Yes.
I'll go back to my nav mesh. And
I love that he's explaining this. This is huge.
This green area up here is considered navigable. Okay, it's a valid nav mesh.
Oh, okay.
However, it is not considered reachable from this person's point of view.
I
Because
see.
you cannot reach that without any assistance. So that's the two differences between the things. If you want the NPC to be able to reach that location, you want to choose reachable.
Okay. So is it going to walk up there? Wait, so then how's that going to work then?
Node here, we have to give
it's
it
going
an
to
origin.
be crazy?
It's going to be the controlled pawns actor location. I'm going to take
I already taken over 3 minutes.
get actor location and plug that in.
Nice and easy.
We then have a radius. This is how far it will look for a random point. I'm going to promote that to a variable. And I'm going to make that variable instance editable. We'll go through why in a moment.
Okay.
Then it's going to output here a location variable and a boolean saying whether or not it's successful. So we're going to put that into a AI move to node. So similar to the one we used last time, I'm going to plug that in. The pawn is this controlled pawn. I'm going to drag that across, and the destination is our destination from that. And you want acceptable radius, you can make that a variable as well, and again promote that to variable, instance editable as well. And then when it's finished, you're going to get on success, on fail, and a movement result. Now a task will, when it goes into a task in that behavior tree, it will not leave that task until it's been told to do so. So a lot of problems I've seen for people is that they forget to finish the execute of a task, and therefore their task will never stop running. So on success here, I'm going to drag out and do finish execute, and we'll tick the success box. Now there's also on fail, and we're going to do the exact same thing again. We're going to tell it that it was finish execute, but it was unsuccessful. There's not aborting it, it's just saying you finished, you just weren't successful at it. You compile and save that. Okay, and that's all we've got to do here. We're going to go back to our behavior tree, and on our sequence here, we're going to drag out and do BT task move random location. location. Now, because I made those two variables instance editable, you'll now notice I've got the option to change these values on this node. I can change the radius and the acceptance radius. So on radius here, I'm going to change that to 1500, and acceptance radius we'll do as 100. And you see the changes here reflected on the node itself. We're going to hit save there and go ahead and push play. So now nothing's going to happen just yet, and that's because we haven't yet told it to use our behavior tree. We've designed it, we haven't told it to run that behavior tree yet, and that's handled by the AI controller class. Let's go into the AI NPC and go to the begin play event, and we're going to do a very simple node just called run behavior tree. So at any point in the game, if you want AI to do something different, you just call this behavior tree and select which behavior you want it to run. Only got one obviously, so we'll just use that one. Save. Now if I push play, you'll see him running about into a random location. Okay, and that is behavior trees and tasks. There we go, we've now taken a brief look into the behavior tree system and how it works. In the next episode, we're going to go through the perception system and how to use it to make the character more aware of its surroundings around the player and the environment around it. So you can join us in that next episode right now over on patreon.com/Ryan Laley. You can watch.
That's also really nice, so thank you very much. I appreciate that. But these videos in the AI stuff is all out, so you don't have to worry about that. His most recent videos is what you got to worry about for the Patreon if you're worried about, like, oh, do we have to watch that? No, that's only when that stuff is not released. But if you still want to support him, go right ahead. Especially in the way that he's explaining this and giving us this, like, not just saying how to do it, but he's explaining the certain things that make it work. Pretty good, but he's given us what we need, especially for moving on in AI and within the series, but just in AI in general. And that's super huge because the more we hear that, if this, this is our first time hearing this, but the more that we hear that over and over and over and over, and then experience that over and over and over, like actually doing it ourselves in whatever way through our own projects or through the tutorials, that just starts becoming like second nature. Be like, oh, that's right, yeah, this is the AI stuff for this, and he tells them for that. So this is actually awesome. So let's get into the next video.
Hello and welcome back to the AI series part 3. In this episode, we're going to go through the perception system, detailing how it works and how to create a site sentence.
Oh, look at that!
A last known location
Session. Oh man.
So, let's get started.
Oh, I love this guy.
So let's talk about the perception system. The perception system is how our AI can detect and receive information from their environment based upon various things that they can see, hear, be nearby, damaged by, etc, etc. And it's a very useful thing to have for many games, so it's good to understand how it all works. So what we're going to do is go into our AI controller, which you have down here, and in our AI controller we can assign our perception system. And when you type in perception, you'll see there's two options. You've got AI perception, this is the system itself, and then you've got the stimuli source. This works in tandem with the perception system when you want to register something to the scene that isn't a character. So let's go and add our AI perception. So in here.
Okay, so for what it means, so if we were using the box, we would use the other option, but since we're using the character, we're using this option. Because we converted the character.
Now,
okay.
On the right hand side, in the details panel, you can see the senses.
This is super nice and easy, where it's just like a thing like this.
Configuration. We can click on this to add any number of senses we wish. So go in here, and then drop down. We've got all the different senses you can add. We're going to choose the AI site config.
Site config?
That is a good one to have by default. This allows the AI to see you, essentially, and react on to what it sees. Once you added the configuration now, you're going to want to open up the settings of this and have a look at what you've got available to you.
Okay, hold up.
Key ones to arrive out. You've got the site radius. This is how far it can see. So if you're within that radius, he can see you. You can lose sight radius. So once he's seen you, how far away do you have to be before he loses sight of you? peripheral vision half angle in degrees.
Wow, this is awesome.
The half angle is the vision cone that you see your character have. So 90 degrees essentially gives you a 180 degree field of view. I personally find this way too much.
Detection by affiliation, enemies, neutrals, friendlies.
Something like 45 or 50. Then you got detection by affiliation.
I'll keep 90. Actually,
so this system is not functioning too well in Blueprint. It's mostly used for C++ and it's mostly defunct. But I would make sure that you turn all these on anyway to avoid any weird issues.
I mean, that's okay. That's good to know.
Next, you've got auto success range from last seen location. So if they're not within a valid range, how far will they be able to see the target if they've already been seen? This is basically their last seen location. Okay. The point of view backward offset and near clipping radius work together to create peripheral vision. The point of view backward offset moves the vision cone starting point backwards away from the actor's origin. So I would suggest putting in something like 200. But to help with this, we're going to clip the first 200 units of the cone. This actually gives you a nice weird cone effect where it looks like you've got peripheral vision in your character. It's a good default one to have.
Interesting.
Debug color is green, max age is 0, and start enabled is done. And that's what we're going to do here.
Okay.
So to trigger this, we're going to right click on the AI perception.
Wait, I'm on the right. Yeah, okay. He deleted, or I didn't. He didn't delete the other thing.
Add event, and you see the events you have available to you.
Oh yeah, the
On
events.
perception updated, on target perception updated, on target perception info updated. These three all essentially do the same thing, but give different parts of information. So, for example, on perception updated, gives you all the actors that have been updated to reflect any changes. So if you're keeping track of who's in vision, who's not in vision, for example, you can do with this.
Oh, that's nice and easy then.
The next one is target perception updated. This is the one I typically use. It's quite useful because it's the one to tell you which actor was just added.
Wait. On target, okay. They look very close. So on target perception updated, not info, just updated. So we had 2 of these. Okay.
Or removed from the perception system. And it gives you the stimulus that was affected by this. And then finally, you got perception, target perception updated, info updated.
Okay.
And this basically is the same thing as this, except this is a struct.
Or is it showing us?
So if I take this out here and break that, you can get that information there.
Okay. Are we using this?
I don't ever really use this one.
Oh, okay.
It's there if you want to use it. Okay, so as I said, we're going to use target perception updated. And basically this triggers, for in case of sight, every time they see you and every time they lose sight of you. You have to give you the actor and a stimulus struct, which you can take out here and break it open to see what it contains. So you have the age and expiration age of the detection. This is especially useful for things like sound, where you want them to hear things and then maybe forget about that sound after a certain amount of time.
I see.
The strength, again, useful for sound if you want to know about like the loudness or something.
Okay.
Stimulus location, receiver location, pretty self-explanatory. Any tag you may have associated with it. These are going to be meta tags you want to add. And success view sense, whether this was a seen or forgotten sense. So what we're doing here is we're going to actually take this and put it into its own function to handle this sight sense on its own little bubble. So we're going to go to functions over here and we're going to do handle sight sense.
Sights.
And with this, we want to pass through the information that we are getting from here, the actor and the stimulus. So let's pass that through here.
Right.
Go to inputs and choose actor.
Actor.
And call it actor. And we also want the stimulus as well.
And he's calling this actor. Okay. And then stimulus. How you spell it?
And the stimulus type, if you just type it in here, stimulus, you'll see AI stimulus come up.
Okay.
Right, so with handle sight sense, we only want this to run this code if the stimulus here is of the sight sense. So you can take from this stimulus here, type in class, and you'll get the sense class from stimulus.
Okay.
You can then, from this class, check to see if this is equal to the sense or site. If I type in site, you'll see AI
sense site.
Site config. AI sense config site. Is that one? Hang on, let me have a look.
With the config site.
AI site config.
Okay.
So it's this here. AI site config. As long as that's the same as this, you're golden. Okay, and we're going to put that into a branch.
Okay.
And if that is false, it's just going to return value here. Okay. So that's the intro to this function. It's just going to check to see whether we are in fact dealing with a site update.
Very simple, but you just got to know what you're doing. Like, what you know to pull out.
A player character. So with the actor, if I type in actor and go right to the bottom, I'll get actor. This refers to this actor pin here. And I'm going to check to see if this is equal to the player character.
So equal to...
Oh, right. Right from here, get player character.
The player character.
And that will go into a branch again for itself. From there. Okay, and if it wasn't the actor, we're going to put another return node in for the false of that branch there. Then on true, we are going to update the blackboard based upon the actor, whether they've been seen or unseen. So we're going to get the blackboard, first of all, by just searching for get blackboard.
Get blackboard.
And from here, we can set a value on the...
Okay, he's getting that, so get blackboard. Okay.
Just blackboard. As object.
Set value as object. Okay. Set value as object.
And I'm going to plug that into my true there. So we have to give it a key name. Like we've seen before how this works. We're going to put in a key name and we'll do make literal.
Make literal name. Okay.
And in here, we're going to give it the name target actor.
Target actor.
And the object value can be based upon whether or not he's seen us or not. So, if we take the stimulus, which is this one here, we'll right click, search for it. Stimulus. Here's. And we're just going to right click and split it. And there we have it.
Oh, wait, hold up.
And what I'm going to do.
Get stimulus. Crap, what did he do? I missed that part, hold up. What did he do?
And we're just going to right click and split it.
Split, oh, okay.
And there we have it. And what I'm going to do is check this boolean here.
Yes.
So for this boolean, we are going to put that into a branch.
Okay, so up here. Branch. Okay. And then he's looking this up. Okay.
And this branch also, this branch can go after the set value as object.
Okay. No worries.
And we're also going to use it for this object value here. We're going to do a select node. So select object.
Select object.
And put select A in there.
Select A.
If it's true, it'll pick the A value. If it's false, it'll pick the B value. If it's true, we want A to be the player character. Get player character.
Okay.
If B, that means false, we're going to leave it blank. That way it resets the value and clears it.
I see.
Now we've got to go into a branch after the fact, because what I want to do is that when it is false, I want to store its location as a last known position. So let's go ahead and do that on the false here. We're going to get blackboard again. And from there do set value as vector. And plug that into the false.
And I just open up Visual Studio by accident. Set value as vector
of this branch. So when it's forgotten,
target's false.
Or lost sight of the player.
Okay.
The key name here we're going to do make and put in last known location.
Last known location.
And this is going to take a vector value, which is going to come from here, stimulus location.
Stimulus location, not receiver.
Okay. And that will do, for now at least, on here. So hit compile and save. Let's
This
go back
was
to
more
our event
advanced,
graph
though.
and add this into our stimulus update over here.
Okay.
So we're going to drag in handle site sense, plug this in, and send over actor and stimulus into there. Compile, save. So when things get updated, it will check to see if it's site sense, and if it is, it's going to check to see if it's the player. And again, if it is, it's going to set the value of the player as the object value here.
Okay.
If it lost sight of the character, because keep in mind, this fires both times when it sees us and when it loses sight of us, so it happens twice. When it loses sight of us, it will set it to nothing. Target actor B. And when it does lose sight of us, it's going to get the vector and put it in a last known location. So we just need to make sure our blackboard has these keys. If not, we have to add them. Let's go over to our blackboard. We've got target actor. And
Oh yeah, we gotta open the blackboard. Oh. Okay.
new key. And do a vector.
New key. Okay. Vector.
And this is going to be...
Wait, you said target actor. What? Okay. Did he do something? I think he was just there.
To our blackboard.
It was.
We've got target actor. And add new key.
Okay, interesting.
And do a vector. And this is
I
going
wonder
to
if
be
that's going to affect us.
target location. When you're adding a target actor, by the way, if you haven't already got it, do make sure you change the base class over here to an actor. So just expand open the key type to see this base class. And hit save and close out.
Wait. Right? No. Or like... Is he talking about like this? Did that work? Okay. I guess we'll see.
Okay, now we're going to go over to our behavior tree.
Oh no.
Go over to our behavior tree.
Yes.
And in here, we've got move to random location. We want to do this where it can't see us, so it's just wandering around. So we're going to right click on our sequence and add a decorator. Now we're going to talk a lot more about decorators in the next episode. Don't worry about them too much just yet. But for now, just go to add decorator and choose a blackboard decorator.
Okay.
And on this blackboard decorator, when you select it, over on the right hand side, you can choose which blackboard key you want it to allow. So we want to use the target actor. And the query is for only when it is not set. So if target actor has not got a value, it will do this branch here.
If it doesn't have a value of target actor, because we put, so we put target actor within the code. So if it doesn't, right? Yeah, so if it doesn't, and then we put that in here within the blackboard as well, so target actor, which is actor. Okay.
But if it does change, we want to stop doing this immediately and then go on to do moving to the player. So we need to take it to abort. And up here, you've got observer aborts, it says none. We're going to change that to self, at least.
Ooh.
Now abort its own branch. And because it's attached to a selector, it'll go up to a selector and do the next branch, which is what we're going to do now. We're going to drag this out here, do sequence, and then on that sequence, we're going to do a move to.
Oh no, wait, what? Oh, there we go. And then a move to.
And this move to, we can go on the right hand side, change the blackboard key to be target actor.
Yes.
Okay. Hit save, and we're done there. So before we leave our behavior tree, let's keep things organized. So I'm going to go to this sequence here. I'm going to rename it from just sequence to roaming sequence.
Okay.
And this sequence here, I'm going to change to chase sequence.
Okay.
It just makes it a little bit easier for us to communicate and talk about these ideas. Okay, so let's save this and put this into the game. I'm going to just get rid of one of these. Okay, so there's my character, and now he's seen me. Now if I go into my debug here, I can access with the apostrophe key. I can
Oh. Hold up, I want to see this. Wait. Oh. But is it actually doing it?
turn off and on the perception system by hitting 4 on my number pad. Now here you can see sight is being updated. But he's not following our roaming sequence. He's still stuck in his roaming sequence. He's not chasing us.
Yeah.
So
that is so cool that we see this though.
On a debug, we can see target actor not being set. It says none. Let's work out why that might be the case. I'm going to go into our AI character here. The first thing we'll do is I'm going to check the spelling for my target actor key over here, which seems correct. Keep in mind, spaces are included, so make sure you've got no spaces there.
Okay.
So if this is not being set, that must mean it's not reaching this far. Now the easiest way to test this, if I right click on my branch over here and do add breakpoint.
Add breakpoint?
Now I have to get seen by him. Okay, so it's not reaching that breakpoint. Let's work out where else it might not be reaching us.
Okay. I've seen someone else do this. This is awesome. Okay, this is actually really huge information he's shown us.
I'm going to go over to handle sight. Add breakpoint for this.
So the game should break if it...
Okay, so there we go. We are hitting the breakpoint.
So it will... That is so cool. So if you're trying to see where the code isn't fully passing through, it will break here. But since it was passing through here, it didn't break. But since it passed through here, it did break, I think.
And you've got stimulus going through here, and return value coming out here. We won't get to just yet. We have to go forward a little bit. Okay, and
oh, and you move it through here. Whoa! Oh, that's so cool.
The sight class is AI sense sight. Ah, we've got the wrong class. That's where we're going wrong. I was wrong at the start. So we're going to just remove our break.
Remove breakpoint. Remove breakpoint. Also in this. So AI. Or actually, which one is he doing? Because there was a third option.
And change that to the other thing. AI sense sight.
Okay.
There we go.
I'll save.
We've debugged that, and we now should see.
There it is.
Give trace to us, seeing us.
Awesome. Oh, that is so cool.
Now, there are many other different senses in the AI perception system, and we will be covering them all throughout this series. So make sure you stay tuned for all of those.
Yeah, that's... Oh,
now, we did add one last thing, which was the last known location. Let's go ahead and put that in there too. I'm going to go into my blackboard, add a new key.
Yeah, I was wondering why we didn't add the other one.
Vector. And give this one called last known location. We're then going to go back to our behavior tree and look at where this is going to go. So when the selector's gone in from roaming sequence to chase sequence, they're in here. Now if target actor gets forgotten about in here, we want to go into a different branch entirely to handle the moving to the last known location. So I still want it to be part of this chase sequence. So what I'm going to do is I'm going to drag this down and put in a selector.
Interesting.
And this selector is going to do this sequence here. And then it's going to do a different move to over here on the right of it. And this move 2 is going to use the last known location.
Oh, blackboard key, last known location. So That's really huge to make them. I see.
I'm going to just take the name of that and up here.
Boom. It's not a sequence, it's a selector.
With a chase selector.
Yeah.
So go into the chase selector once it's been seen. It will then pick the left-handed branch, which is this one, to chase sequence, and do the move to target actor. We then want it to abort this. So if we right-click on the chase sequence here,
Add blackboard,
go to Add Decorator, Blackboard, and do what we did over here, basically.
and
So we're going to
then
click on our blackboard base condition, change
set
it from
actor
self-actor to target
or
actor,
self-after.
and it should
and then
only do this if target actor is set.
Yeah.
Okay, so if it is set, it will let it through. But if that gets changed, we want it to abort. So observe
Blackboard condition. Okay.
aborts, change that to self, and that will leave that one and go back up to the selector and then to move to last known location. Now, if it was going to there and it sees us, currently it will just keep on going to that last known location. We need it to abort this as well and go back to here.
Yes.
So we go back to target actor is set on here and change it from self to both. And now you can see it's highlighted blue.
Oh, okay.
Both directions on here. Hit save, and let's see how this looks. Those get seen by him. If I run around the corner, he won't just wander off. He'll keep chasing and following where he last saw me.
Okay.
Until I lose him completely.
Right.
There you go.
Which I
He lost me
could.
completely. Okay.
Will
There
it
you
show
go.
me?
That's how we do last known location.
No, you said press 4. There it
And
is.
there you go. We've now got sight added to our character. Now, I did say we will be going back to this later on when we're adding other senses, but for now we're going to move on and go on to decorators as we teased in the episode. So the next episode we're going to go through decorators, what they are and how to set them up, and also create your own ones too.
Oh, this
You can
is
watch the
so
next
cool.
episode right now over
Yes, he's trying to find us. Oh, now he found us.
/RyanLady. We can watch all
This is
my
actually
content
pretty
available
advanced.
early from just $1 a month. Massive thank you to all
Yeah,
my
I get it,
patrons
man.
and YouTube members for their continued support. Thank you for watching. Make sure you're subscribed, and I'll see you all next time. Bye, everyone.
Heck yeah. 100% support this guy. It's super huge. Because this type of information, especially with all, again, this type of like just tilt up and then pressing 4 on your numpad key, you get this information. And you see like the lines that are kind of like the perception vision. This kind of reminds me of Dark and Darker AI. And how they would just continue to follow you, and it's like, how? Well, it's because of this, and I see just how it is. But I think it's because they needed to adjust the AI because it's too strong, which is easy because you see the age. It's increasing age 2, 3, 4, sight 1. You would just adjust those settings to make them less extreme so they don't follow you through stuff like this. Learning this so far, this has been pretty awesome because this is unlocking that stuff that's really going to be crucial like later on in certain games or whatnot. So this is awesome to get into. Yeah, let's get in.
Hello and welcome to part 4 in our AI tutorial series. In the last episode, we started taking a look at the perception system, and in that we had a little brief glimpse of decorators. In this episode, we're going to go through decorators in a little bit more detail, talking about how they work, what they do, and what settings they have available to them, as well as how to create your own.
Yes.
So let's jump in and get started.
Ooh, let's go.
So previously, we mentioned decorators when we looked at senses. So let's go into our behavior tree, and you can see we've got 2 decorators already assigned over here.
Yes.
But what are they? So decorators are basically add-ons that will allow or block the flow into that branch or node.
Allow or block. So not just blocking, but also allowing. Okay.
The way I always think of it is like a gate. So it sits on top of this thing, so that's the first thing that gets hit, and it's a condition. It will check to see if it allows it through or not. Now the one we've been using is the blackboard base condition, which is quite a useful one. It's basically lets us check to see a blackboard key and see what its value is. And if that value is a conditional value, then we can make it work for that. Now, but there are many others. So if we were to right click on any node, you go to add decorator, you'll see a load of decorators already made here. So let's go through in a little bit more detail about some of the key ones that I find very useful. So first of all, we've got Blackboard base conditions. On Blackboard base condition, over here you've got Blackboard key and key query, which we mentioned last time. This allows you...
Sorry to pause, but I love the way that he explains this. This is huge.
Just set a key and whether or not it should be set or not set. Now if you're...
Wait. Oh, that's right. It's flipped. So, in 5.10, this is flipped upside down. So, okay, so is set. But that is different, though. Yeah, target actor. So no wonder that wasn't working, right? Blackboard key, target actor. Okay. That might be why the... Oh my goodness, we actually just fixed it. So when the AI now looks towards us, it's now going to go down the second branch, because last time there was an issue and I tried to debug it, but it took a while, so I didn't want to, you know, like keep working on that and try to figure that out. Of course, now I see this right here. Hold up, you know, not the exact same thing as the last time, so if we go in... Also, what was the key? I know it's 4. Will it do it? Yeah, you see him? You see, oh, there. Yep. Okay, well, that's easily to tell. Last time, that AI would just continuously follow us nonstop. Right then and there, that, yeah. Okay, so it's fixed. Awesome. So now it's actually going to free roam, and then once it sees us, it's going to start following us. Before, it would just continue to follow us. I was like, why is it doing that?
If you're using a float value or integer or any other value like...
Oh, because, okay, Blackboard key, last known location, and then target actor. Okay. And then oh no, it was target location. So interesting. I wonder...
That, this will allow you to also check if it's equal to, greater than, less than, and so on and so forth.
Yes.
And that really does allow you to check those values in greater detail.
Okay.
And furthermore, that also relates back to notify observer. Now, notify observer will be on results change or value change. Now, when you're dealing with something like this, it doesn't really matter which one you pick. But if you're doing things with numbers, it's very important, the difference. When it's doing numbers, on value change means it's when the value just changes to any number, doesn't really matter. And then on result change basically means whenever this changes from being true or false, essentially. And that's the Blackboard base condition. Another useful one, when you go into add decorator.
Okay. This does... Okay, so I love how he's explaining this. So, now, of course, this is like basic explanations. Then there's like the in-depth where you can go in and like deeply explain each one. But this is really good to know.
Cooldown. Cooldown basically blocks this node being used after being executed for a certain amount of time.
Oh, I thought you said tag cooldown. No, just cooldown. Cooldown.
That amount of time is determined over here on the cooldown time. 5 seconds by default. So when it hits it, it will fail after 5 seconds.
Excuse me, I'm finish eating my bagel, but the cooldown, that is actually really simple, but a big thing. Which might even be good to kind of use here, right? The cooldown, maybe to make it a little bit more realistic in some way. I don't know. Would a cooldown just make them stop in place? Because maybe that's why we would want that. Cooldown waits like a chicken. If we want to make them more like a chicken, maybe you would put a cooldown. Wait, does that?
The one is going to be is at location.
Ooh.
You can click on this, and you can determine whether or not something is within range or something else. So it's very useful when doing like attacking or interactions or anything like that. It's very useful for handling that sort of information. You can give it what kind of radius you are looking for. You can also put in a parameterized radius if you wish. Rest of this you can leave pretty much alone, apart from inverse conditions. So if you want it to do it when it's not within range, then that's where you want to tick that on. Go decorator again. Next we got keeping cone.
Keeping cone, okay.
So this allows you to put in basically
these are pretty simple.
A conal degree basically, and it's going to pick 2 actors essentially, And the actors you want to keep in the cone are going to be based upon who's watching who. So, for example, cone origin would be self actor.
Yeah.
And observe maybe target actor. Okay. And that will keep them in view of that cone. If they're not, then it will fail and make them look elsewhere. Okay. Keeping cone pretty useful.
That's a little bit more confusing, but I guess I
lets you check it
generally understand it.
Another good one. You go to a decorator.
Cone of what?
Is going to be loop.
Loop. Okay,
so loop
that's easy. We loop 3 loops.
However many times you take to. Okay,
Infinite.
So
whoa.
number of loops default is 3. And basically it detects whether or not that loop has been exceeded.
That's awesome.
So go through 3 times and that's it. It'll stop after that.
Why would you want to do that?
Now decorators can also be made by you too. So
there's probably a good few things that you could use for that, but I'm thinking like an animation. Would you just want to have that on a separate thing though? Or if you're looping this like 3 times, like maybe it's like a chicken, like just looking around or something like that, and then it moves. So you want it to loop, or like if it turns in a different way. I don't know.
We may say on this chase selector here, decide whether or not we're going to chase us or run away from us, based upon a condition on the player that's always changing.
Wait, chase from us?
So for example, I can go up top here and do new decorator. And that's where I want to name it. So I'm going to call it BT decorator, and then we'll call it check value. No, check. What should we do? Check scale. Okay.
Check scale.
And what we're doing here is on the functions override. Override here, you've got a few options you can choose from. And the most important one is this perform condition check.
Perform on condition. Oh. Perform on condition check AI.
This is the check that happens to allow it through or not let it through.
Okay.
So on this perform condition check here, we can do various things such as look up any type of value we wish. Let's say I want it to look at the scale of the object that we're trying to chase, that is seen. Okay. So if I go into my variables here and give it a blackboard key of the target, and give it the type of blackboard key, like so, and we're gonna make this editable, so we can change it in the behavior tree.
Okay.
And I'm gonna take this target out, and I'm gonna get value as actor.
Get value as actor.
I'm then going to get this scale of this actor. I'll take that. I can scale, and I'll see get actor scale 3D.
Okay.
Let's give me a vector based
nice
on
little
what size they are on the X and Y
nodes
and Z.
here.
And what I'm going to do is I'm going to do a vector length on this to summarize it all into one single float. So vector length. Let me do that.
Okay.
So if your size is 111, the value will be 1. 222, value will be 2. Okay. So vector length here, we want to check if that is above or below a certain condition. And that condition could be a variable as well. So let's put in vector length here, and we'll put in greater than. Actually, no, let's do less than.
Oh, okay.
Less than, and promote this to a variable. And we'll do this one as max acceptable scale. And this boolean here will now go into our return node there.
Right.
Now this max acceptable scale, I'm going to make that editable as well. And set its default to 1.
Okay.
So
what is this going to do?
Higher, go 1.1. Okay. Let's put this onto our behavior tree. Go to our behavior tree, and there's chase selector here. We're going to right click on this and do add decorator, and we should see our decorator here for check scale.
Oh,
on this, and you can see those values that we set to be editable are now appearing.
So if you want to create your own,
we can click on this, and on the right hand side we can choose the
There's
target.
Your goodies. Oh,
target actor, and max acceptance scale here we'll leave as 1.1. So if our character we are set the target actor is below the size of 1.1, he should chase us.
you get somehow shrunken and now the ants are coming after you.
But we also want to make sure this only works if this was in fact valid. So let's take the blackboard as value here and type in valid.
Okay.
And do in this valid node. And chuck that into there. Okay, and if it is valid, great, move on to this. If it's not valid, we're going to put in the return node and leave it as false.
Okay.
Okay.
So what are we doing? Let's see, right?
So now, when he's running around,
I need to save.
he will ignore me. Now, he will still register and still see me, as shown by the perception system, but he isn't going to respond to it. Okay?
What is mine doing, though?
And there you go. That's
Is
decorators.
Wait. Maybe 1.5? Oh, okay, there we go. Okay, then boom. Boom. Yeah, so he's looking at us. He sees us. It seems like he's like interested. But it's like but he's not though. Hey, what is going on? If I do this, I feel like that's a bug. So will he just stay around us? So he's not chasing us, but he just will stay around us? I mean, this is a kind of a cool AI. Imagine like a animal model or something like that. Like just random interest. Because I'm just like watching this. I'm trying to think of like what the heck is going on here. Because it kind of looks like he looks over, gets interested, like, oh, what are you? Like that's actually pretty crazy. But I don't think is it what it's doing? I don't think that's what it's doing. Because how would it register that stuff? You know, it's like, okay, so it sees it, so it's like, oh, what is this? It's not what I think it is. Okay. Is that what it's doing? And then when I move, it's like, okay, let's check over here. Because it can't see me. Now it sees me. Did I set the right things? Did I do the same thing? You said target actor. Either way, this is a big video, though. So if we zoom back to this.
And there we go. We've now got decorators covered. In the next episode, we're going to go back to our perception system and take a look at the sound system. So how to make him hear whistles or footsteps from our player character and for him to go investigating for that sound. You can watch that next episode right now over on patreon.com/RyanLady, where all my videos are available early for just $1 a month. Massive thank you to all my patrons and YouTube members for their continued support. Make sure.
Hey, shouts out. Yeah, subscribe to him. Huge help in this stuff, which I'm super excited to get back into because this time we're going to be doing some hearing perception in the AI stuff. So that's going to be pretty sweaty. Nice sweaty flamethrower. Jeez. Gotta be careful of that.
And welcome back to our AI series. In this episode, we're taking a look at the hearing perception in our AI perception system. So previously we've done the sight system, now we're going to do sound so they can hear us as we jump around the place and make lots of noise. So let's take a look at how this works.
I didn't see the green boxes.
Look at how we do sound. So at the moment our character is going to see us and chase after us. But let's make it so that our footsteps make sounds as well as certain objects in the scene make sound too. So first thing you can do is to set up the AI perception component to receive sound inputs. Let's go to the AI controller for our NPC here. We go to the AI.
Okay, hold up. It's taking a second to load. Again, I appreciate you so much for the follow.
AI perception.
Oh, that's right. We put it on. Oh, that's right. We put it on the AI NPC. Okay.
Component. And on the right hand side, I've got sight already in there. Minimize that and just add another one, and this one is going to be the
that easy
configuration. Now this one doesn't have much in terms of settings.
Super easy.
Mess about with are going to be the detection by affiliation. We'll turn that on for all of them, and also the hearing range. So you can customize this as you see fit for how far away they could possibly hear. However, this is a multiplier value, so you can get large numbers. You can also get smaller numbers. based upon the volume of the sounds you play. So I'm going to leave it as 3000 for now, but you can tweak that if you so wish.
I don't know what this is going to reference, so we'll try it out.
We now need to set up the AI perception target perception updated event here to handle the hearing sense. So we made a function last time to deal with sight sense. We'll do something similar this time for the hearing sense. Now hearing is interesting because you're never going to tell them exactly who caused the sound. You're going to tell them where the sound came from and for them to go over to that sound. Okay.
Oh.
So let's go ahead and create.
Interesting. To go over. This is like specific. This is really specific stuff that we need to keep in mind because the terminology, especially with the type of side stuff that I've been doing, that's very important. Just like kind of keeping, like if we're going to use actor, whenever we want to reference actor, we have to like use this, or I'm just kind of bad examples, but like we got to keep the variables consistent, the names consistent, like that. Those are like small things, but very important things that you'll find out. Oh wait, the stuff is bugging out because guess what? I didn't do it in this way because because you didn't realize that's actually something you got to do.
Right, a new function called handle.
Oh, that's okay. That's right. We're going for functions.
Sound
New function.
Sense. Okay.
It's handle sound sense. Okay. Sound sense, because our other one is handle sight sense, so this would be handle sound sense.
And this will start the same way as we started the sight sense, where we get the class and we check what class it is. So let's just copy this over.
Let's go about this right here. Okay. Easy. That's something I'll be doing so much, and I highly encourage copy and pasting. I mean, it's huge.
Into our sound function. And the stimulus here we want to put
and this would be the
into
hearing.
Our functions inputs.
Yes.
Obviously, we want to change the equals here to be the hearing one. So
hearing.
Hearing. And we want to do AI sense hearing.
Okay.
Put that into a branch.
Nice.
Okay. So the way this works
it does. Okay, so branch, I'm like, I wonder what the keybind would be. Because it starts with a B, let's try B, left click. There we go.
Once he is walking around, we want to interrupt what he's doing and give him a new target location to hit. But at the moment, let's have to go back to my behavior tree. He is moving around.
I'm going to actually hold up. Let me reset this because we did this the last time. And I didn't remove it. Did I change this too? No, I think that's good. Or it's both. Yes, that's self. Okay, that looks good.
Around is moving random location. I want to change this so that it doesn't do randomness if he's got given a target location. So the way we're going to do this is we're going to go to our blackboard, and we've got this target location key we're going to be using. So I'm going to feed this into my behavior tree. Let's go back over to our behavior tree, and in here in the roaming sequence we're going to add an investigation section. So with roaming, I'm going to break down here, and we'll do a sequence.
Interesting.
And we'll put that on the left of our move random location.
Oh, okay.
Now the reason why I'm putting it on the left is because I wanted to check this first before it does anything else. Okay. So sequence here for this. Sorry, we want to change this to not sequence first.
Find some stuff on Google. Hey, I appreciate you very much. Thank you.
Selector. And then into a sequence. And this move random location here would also go into a selector as well. The reason why we need a selector is because...
Wait, did he just... Okay. I looked away for a second trying to do it myself, and then it's like, boom, now he did that. Hold up.
This move...
So how did he... Wait,
how did location here would also go into a selector as well.
Oh! Oh, so it'd be... Selector. Boom. Ah, I see. I didn't know you could do that in reverse, so then... Boom. 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 There we go. Nice. That's
the reason why we need a selector is because we want it to do one or the other. We don't want it to do both, because this is currently a sequence. So the selector will do left hand first. If it fails, it would then do random location.
Right hand, okay.
The decorator for this.
So what are we doing here?
Right click, add decorator, be a blackboard key.
Oh,
and
that's
the
right.
key we want to check is going to be that target location. So you just go to blackboard key, target location.
Target location.
And we're making sure it's set to something. Okay, so
Is set. Okay.
However, if it does change or get told to do something else or whatever, we can set it to abort things as well. And we mostly want just to abort itself if we do clear it. Okay, so if it changes, so if it gets given a new target location, so a new sound, it's going to abort itself and then carry on going.
Oh, okay. Right. That's good.
So on this sequence here, we're going to do move 2. And this is just a built-in move 2 here.
2,
and
then
give it
2
the
target
key
actor.
for target location.
Or target location. Oh, that's right, because it's hearing. Right? Or yeah, the target's location. Yes, that's okay. That's what that means. Targets.
And obviously here we can put in things like acceptable radius and things like that. Totally up to you. What?
Oh wait, hold up. Acceptable radius of like. Okay, so this is going to the point. So acceptable radius of that point itself. I'll just leave it at 5 because I don't know how aggressive that's going to be, or if that's like a good measure. Because it doesn't. Why doesn't it say, "Hey, little info bar. This is centimeters. This is whatever." That would be so sick. That's actually kind of crazy that it doesn't have that number here. Nowhere to be found.
One thing you may want to do though is turn on observe blackboard value. So I'm going to turn this on here. Now, as I said with target location, this will abort when it changes.
Okay.
What I actually want to do is change it so it doesn't abort when it changes, but it aborts when the result changes. This key query changes from is set to is not set. So up here, when on result change,
value.
I'll say result change is that. That's what I mean.
Yeah. Okay.
Value changes if we change different location.
Okay.
So if result change means it's being set or unset, value change means it's different numbers. So at the moment, I'm going to keep it as result change, abort itself, and that means if the target location is then cleared for whatever reason, it will stop doing its thing. But the move to here, I'm going to take it to observe the blackboard value. So as that value changes, it'll update and change its location according to it. The tolerance you have here determines how much it has to change by before it determines that it needs to change. Okay, so that target location is there.
Interesting. So that one we might have to adjust.
Our AI NPC.
Most likely.
And in our
save
stimulus handle sound sense here, we are going to take the stimulus input. And I'm going to break it open to get hold of that data from our sense. And most importantly,
okay. I gotta spell it all out, Jesus. Okay, and then break it. Break. And then expand.
We want the stimulus location.
Okay.
So on true,
I've been doing this more and more, and understanding this break node is actually becoming almost second nature. Which is like, whatever that I want inside of this, break it open. So you get all these values. Which makes sense because then the next stage is like what you want, which is what we're going to be doing here. Like the location. The location.
Set.
Not really everything
blackboard.
on it.
Oh, I have to get blackboard first. Get blackboard.
AI.
And then from there, set blackboard value.
Set.
Blackboard value as a vector.
Vector?
And put that in there. Okay, with that in now in true, on key name, we're going to drag out and do make and put in target location.
Make. And then this is target location, which is the blackboard target location, which is a vector.
Okay.
Yes. I want to do this first.
So target location will investigate that noise and so forth. Now, if it reaches that location, I want it to clear that value. So let's go back to our NPC's behavior tree here. So we're going to go to move to target location. If we successfully reach the target location, we want it to wait and then clear. Let's put in a wait here. We'll wait for...
just straight up like that?
3 seconds, maybe. You can put a random deviation if you like there too.
Because we don't have to put it above. It's just going to go left, right.
A really useful task here to clear blackboard value. So I'm going to go into create a new task, blueprint base. I'm going to do BT task.
Create a new task. Okay, blueprint based. Okay.
Clear blackboard
clear.
Value. And I recommend making this for any AI you're making. It's a pretty strong way of pretty often used.
All right.
Rather.
Good to know.
Yeah, so we need to make a function for execute AI. And then what the purpose of this is just to clear any old Blackboard value. So you need to put in the Blackboard key selector in here. So Blackboard key. That would be a type for a Blackboard key selector.
Key selector, yes.
And then I'm going to drag this out, and we're going to do clear Blackboard value.
Okay.
A super simple one, not complicated at all, but it does clear it. Meaning that vector, you can't just set it 0, 0, 0, because obviously it will go to 0, 0, 0. Clearing just means it empties it out completely, has no value whatsoever. Don't forget to put in a finish execute and tick the success box.
Finish execute.
Done. So
clears Blackboard? Yeah, I guess. For a value? Yes.
let's put that onto our sequence here, and this will be our clear Blackboard value. Oh, I forgot to make it editable. So if I double click on this,
boom,
make the variable here editable by clicking a little eyeball.
Oh, that's kind of good that he kind of messed up so we can see what.
Now choose which Blackboard key I want to clear. Now I'm going to choose the target location. In this sequence here, we're going to name the investigation sequence.
Oh, we're renaming it. Okay.
Right. So it only does it if it's been given a target location to go to. Otherwise, it will do is move to random location.
Okay.
The NPC is only going to respond by going to that target location. Site, we should be using it at all. We're just using the last known location. That's all good there.
Last known.
So now we've got to make it generate the reporting of the noise event. So what we're going to do is make it so that when we jump and land, that landing is going to cause a noise. Let's go to our characters animations here and go to
characters animations. Ooh. So character. Actually, wait. Where is he getting that from? Characters, mannequins, animations. We're in Quinn though. So landing or land. There it is. Okay, interesting.
And in here, we're going to find the position of where we land on the floor. So, hit a start here. Notifier track over here. We're going to right click on this and go add notifier. Do new notify. And we do landed.
Whoa, okay. Hold up. Chill out there. Dude comes in just like rapid fires that. Okay, hold up.
Yeah. Notifier track over here. We're going to right click on this and go add notifier.
Add notify.
New notify.
New notify.
Do landed.
Landed.
Okay. Push. Hit save, and then we're going to go over to our ABP Manny.
ABP. Oh. Quinn. Okay.
Which is our animation blueprint. Now, because...
Or should we... Wait, which one is he on? Wait, I'm confused, because they did change that stuff, but I guess we gotta use Manny? Is Quinn just a child? Oh, is Quinn a child? Oh, Quinn is a child! Oh, yeah, Quinn_C, so it's a child blueprint of Manny. Oh, I thought it was just a separate thing. I mean, it says C2, but there's that stuff, and then there's that. Okay.
A notify is made on the animation, it's actually tied to the skeleton. So because this shares this same skeleton, it will also appear here too. So if I right click and search for landed, there's my event notifier for landed.
Okay.
And we're going to do a couple of things in here. First of all, we just want to check, make sure this is only the player generating this noise. So we're going to get the owner. Try get pawn owner. And also want to get the player character. And see if these two are equal.
Try to get pawn owner?
If they are,
and then get player king character. Okay, so get player character.
We're dealing with the player's animations, not the AI's.
Is equal?
They're sharing the same blueprint.
Okay.
Then to a branch, plug that in. And then
that is pretty fast to use.
We're going to take the
left click
from true here and do report noise event. And so whenever you want to generate a noise that can be heard by the AI, you need to call one of these.
Okay.
Now, it does require a few things. The first thing it requires is the noise location. So we get the try get pawn owner and get the actor location for this and plug that in. The loudness is the multiplier. So this is how loud you want this thing to be. So for example, our range was 3,000 in radius.
Yes.
If we're putting 1, it could be heard within the full 3,000 of that radius. If I put in 0.5, then that radius will now be 1,500. Okay, so it's a multiplier for that radius.
Oh, okay.
I'm going to leave it as 1 because next I'm going to use is the max range. This is how far away it can be heard from. So I'm going to put in
Interesting.
Like 300. Okay. Actually, no, let's do 500.
Wait, what?
Now, for this to actually work, though, you do need to make sure you give it an instigator. If you do not give it an instigator, it will not work. So,
okay.
Okay. Chuck it into instigator there.
I understand it works like this, but that's a little interesting.
To help test this out, I'm going to put in a print string in here. I'm going to call it landed. And hit compile and save that.
Compile save.
Okay, and so the last thing you need to do is go to our AI controller and add in our handle hearing sense. So let's go handle sound. Plug this in. And this requires the stimulus.
Oh no. Going to the event graph. Handle sound sense. Okay. I see. I really do like breaking this stuff up in functions. It is really nice and neat, and it makes like the event graph itself clean. Then you got like all the mess in the actual functions themselves, because this all would be here. So this would be super massive.
So.
Stimulus.
Okay, so let's go into our game here.
Yes.
So I've moved the AI here around the corner here, and myself around the other corner.
Probably a smart thing to do.
Get seen by him.
Yeah.
Yep. And let's put on the debug. So if I jump now, not going to hear me because I'm too far away. So if I can get oh, you see me. If I can get near him.
Oh. Did he?
Yeah, you heard that, and he turned around immediately. Okay.
I don't know though.
Now if I turn off that range, so you can see it working at full length. I'll change that range back down to 0. It will make the
no, he saw me.
Range maximum match their radius. So if I jump now, there's a sound, and he should now walk over to that point.
I see. Wait. We go here, so max range 1,000? I don't think that's working. Oh wait, hold up. Okay, so hold up, what did he just... Okay, so he multiplied it? Because I know... Okay, so... Let me see.
Match their range down to 0. It will make the range maximum.
Okay, 0. Okay, that's... Okay, so 0. Save. Oh, there we go. Oh, now he's hearing us. Still is not the best map to test this stuff. Oh. Was he stuck there? Why did he pause? Ah, so yeah, you see he went to our last known, like, hearing location. Oh, he stopped. That's what's happening. So he went to the last location. He investigated. Now he's moving. Oh, that's so sick. That is so... Okay, that's actually pretty basic to make something that kind of complicated. Because that's, like, pretty... That could be a scary AI boss type of thing where, you know, we're playing a scary game. I mean, it could be as simple as that. Add a few extra things on it, and boom, you got that.
Their radius. So, if I jump now, there's a sound, and he should now walk over to that point there.
And it's so interesting to watch them think about it, too.
Wait.
Yeah, it waits. That's so cool.
And then he'll clear the value and continue roaming around.
That's so cool. Because you can put an animation there that triggers, like, him kind of, like, going down, digging, like, yeah, you know, doing that stuff.
Sound there. Again, if I jump here, it'll override it and go to this one instead.
Okay, so he does. Okay.
Oh, damn, you see me.
I see.
But there you go.
Oh, so it's just that? Wait, what? Okay.
There you go. We now have our second system in there for hearing. So now they can hear us as we jump. But we can also tie to other things like when we shoot. We can do report noise events. We can also do report noise events for throwing things like stones about. All these sort of cool uses of that system make the AI investigate an area that they're not normally investigating. So in the next episode, we're going to take a look at making patrol paths and look at how we can create a patrol path using a new AI behavior component that we're going to create from scratch. You can watch the next episode right now over on patreon.com/Ryan Laley, where you can watch all my videos early before everyone else from just $1 a month. Thank you to all my patrons and
shouts out. Huge.
Support. Make sure you're subscribed, and I'll see you next time. Bye, everyone.
Heck yeah. Huge thanks to this guy. All right, let's get in then, because where we left off last time in getting into the AI, we got into the, we did the hearing, right? I'm pretty sure we did the hearing, because we did the hearing perception, which is kind of like, in my mind, getting blended in with the perception system, what we kind of did earlier on, because they are very similar, and it's legit just like attaching the AI component, like having that, and then having the AI component in, and then just changing the settings within there. But what we'll be working on now, which is something I'm super excited with, so let's dive in, shall we? Apologize.
Hello and welcome back to our AI series. Previously, we've been working on that AI to see us and hear us, but now let's give them something to do. Let's make them patrol an area via a patrol path. So in this episode, we're going to set up an AI behavior component and create a patrol path system to allow our AI to navigate around the patrol path until they see us.
I want to know what those things are.
Let's get started.
But so unfortunately, no Peabody for now.
Patrol path thing. We need to have a patrol path indicator somewhere where we can indicate what route the AI
so
can
it's
take.
already built in. We're not making.
Let's go ahead and create a new actor type. And we're going to call it here AI object
actor
underscore patrol path point. And we're going to go.
Hold up. Had to be sure I don't spell that. What is that again? That is AI object patrol path point.
Go in here. I'm going to give this a simple sort of debug look so we can actually see it in the world and place it wherever we like. So let's go ahead and give it a simple let's go
it's
for
loading.
And
then also I found how to actually save like project settings, because that's like a default setting where it auto just ejects it. So that's something I'm going to like do pretty soon and go like probably through a lot of settings and adjust them.
Let's go for a static mesh and give it a cylinder. And choose upright one like so. But I'm going to squish it down. This.
Oh, so we are creating it
a little bit bigger.
Okay. I'm like, wait, what are we doing?
And I'm going to give it a different material. So something I can use a debug material for. I'm going to go.
Yeah, hold up. Let me make sure this is. Is that like? Is that zeroed location? Yeah, that's zeroed. It's just a scale. Okay. And then so we're creating material. So space, then. Characters AI material.
Go to make a new material and do debug. Let's do debug.
Oh, this is this is so cool.
And in here, I'm just gonna give it a blank color.
Yes.
B into our emissive color.
Green.
And I'm gonna change that to, let's say, green. And I'm gonna change the type here from opaque to translucent in the blend mode. I'm going to change the shading model as well from.
Okay, and then boom, color. I do want to have it green as well. Boom. How's that gonna look? Oh, that's right, because we gotta do that. Hold up. Boom, green. Because this is a debug color. I mean, I'll try it. Because I might want to have it more like that.
Default lit to unlit.
Oh wait, hold up.
And then in opacity.
Wait, blend mode. translucent, and then shading model default lit to unlit. Okay.
See, we're going to put in a scalar value, which is 1 left click to create that.
Yes.
And the scalar we're going to set to 0.6. Okay, and there is our debug. In fact, let's make it a bit lighter. Let's do 0.3. Okay.
Oh, I see.
And
Okay.
if you want to, you can render two-sided if you like.
I might do
so
0.6.
you can look a bit better, look more interesting. As the shape goes, but
Do both sides? So two-sided? Yeah, two-sided's actually pretty huge. Which is something that I'm finding to be somewhat of an issue on certain textures, on certain objects that I've been like using recently, but it's really nice though.
that would do for us.
I just gotta account for it now.
So let's apply that to our patrol path point. Go
Okay.
into here, debug, and I do M for debug.
Is it not saved? Oh, okay. It's just not
It is.
loading the
I also
shader.
want to turn off all
Compile.
collision on this as well. So let's go down
Oh, okay.
and change it to a no collision. Okay, it's
No
just there for
collision.
visual aid, so we know which
Yes.
way or where it's going. So we also want to add an arrow into here.
I was
This
about
will
to
know
say
which way
an arrow.
we've orientated it. So put an arrow in. And this arrow, we're going to just rise up a little bit off the ground. And I want to make it a little bit bigger. So let's go change the arrow size here to like maybe 1.5.
Oh, it's got its own.
And
Whoa.
that's good. Go.
Its own size thing.
You know,
That's
facing
awesome.
X, if you haven't really got it facing X. And the reason why we're using the arrow is because
Wait,
we can use
making it facing X? Okay, it is.
it to help us
default.
debug which way we want the character to look when they get to that patrol path. Okay, so we're going to save that, and we can close that now. So the idea is that we can drag these out into our
Take a
scene
pause, save.
as indicators of where the patrol path would be. We can just drag this out, like so.
So this is here. Why is it not saving? Or compiling? Is it compiling? Alright, is it because I didn't save? Oh, it's because I didn't save. There we go. Okay. I do want it to be... Oh. That's right. Crap, it's going to scale down the arrow as well. Okay, so I'm just going to delete the arrow real quick. Actually, no, because you want the... 2? Or 1.5? Yes. And then quickly, arrow. And then this is where we go. Oh, click on the arrow. Go over here, 1.5. There we go. Compile save. Make sure this is on. Oh, yeah, it is on always good. There we go. Looking good, looking good. So what do we do now?
So, and move it around as I see fit. Now, as you can see here, we're getting some Z fighting because of the collision. Sorry, not collision. The size of the shape and its positioning. So I hope you get rid of that because it's annoying. It doesn't actually do anything bad for the game. It's just an annoying thing to see. Let's go to our static mesh here. I'm just going to
Okay, static mesh.
move it down a little bit so it clips through the floor somewhat. There you go. And let's get rid of
Okay, so it'd be like... Actually, I'll just manually do it. So like that? I mean, would just 10 work? No, because, okay, it wouldn't. So... Wait, Control Z. Movement. There we go. Nice. Awesome.
that annoying little flashing going on there. So let's add in a couple of these to make a route. And so I'm going to duplicate this across, like so.
Oh.
And
Did 2 times by accident.
this. Okay, so now we've got a patrol path points there set up. These could be key locations along in your level, or whatever you want to do for the AI's positioning. Okay, so next thing we do is set up a way for to
Why is he doing it separate?
assign these patrol path points to our NPC. Now what we're
Okay.
going to do here is going to create a component that we can drag and drop onto our NPC to use a patrol path. So let's create a new blueprint class and choose an actor component. And we call this one an AI behavior component.
Oh, actor component. Okay. AI behavior. AI. Just behavior. Okay. AI behavior.
And we're going to go onto there.
Double
And
click.
we're going to add the variables patrol
Whoa.
path. And the
Okay.
patrol path is going to be a map.
We're doing it like
So
this.
let's change the type here to patrol path. Point. Object. And in here we want it to be a map.
Okay,
So
object
change
reference.
it from single variable to a map there. And we'll
Ooh, a
change
map.
it from an integer to a float. Now the reason why we have a float there is because
Ooh.
then what we're going to do later on is make it so that when we reach a point, we can use that float to determine how long it should wait at that point before it moves on to the next one.
Yes. Okay.
So that's all good. Next, we want to make sure that instance is editable is ticked, and hit compile and save that. Okay.
Awesome.
Next, we're going to go into our NPC and add that component to their actor.
Open blueprint.
So add AI behavior to their
AI behavior.
So we'll be doing other things later on in the series as
that's
well,
so
where
easy.
we're adding more to this component. So it's going to be really useful for us down the line.
Yeah, that's so awesome.
Right now, all we need on there is the patrol path stuff. So
Okay.
that's all good. Compile and save that. Now, if I click on him in this scene and scroll down in the details panel to find AI behavior, I should see the option to insert patrol paths. I can click on here.
Whoa,
choose
that's big.
add,
Okay, so you can actually... Oh, that's huge. You can click on this stuff. I have been kind of ignoring that, but now that's actually becoming huge.
and I can pick a route out for each one. So just add in sequence the route he should take.
Okay. Oh, it did not work. Let me do this.
Like so. I can use these times
no,
here to
it's doing
determine
it.
how long you should wait for each one. So let's do 0
Oh,
seconds
that's
for the
so
first one.
sick.
1
Hold up, let me do that. Hold up, let me do it real quick. Boom. This is so familiar to when I was using Men of War Assault Squad 2's engine, the gem editor. But you don't do this, like, but you just place them, and you gotta type in this stuff. This is much easier. Duplicates are not allowed. Okay. I guess I'll do this. Maybe finish his path over here. Wait, where'd I go? AI. Behavior. Boom. Okay. And then the weight, so it's like, boom, 10. Okay.
1 second for the next one. 2 0 and maybe 3 for
I
the
wonder
last one.
if we could have a thing where if we set
So
it, it changes
he
the
will
color.
be waiting at each one of those points.
Because that is a little
Save.
confusing.
And next thing we do is go to the behavior tree. So in our behavior tree, we've currently got this move random location. So rather than doing move random location, we'll be doing something different instead. We'll do a patrol path.
Oh.
But we only want to do patrol path if we don't have a patrol path. Sorry, we don't want to do random location if we don't have a patrol path issued. So what we're going to do here is have another selector coming off of this.
Yeah. Okay. Oh,
and
selector.
Plug that in there. Now, we're going to make another task here to do the patrolling. If the patrol fails, because it doesn't
I didn't
have
mean to do
one,
that.
it'll
Hold
just go up to...
Oh. There we go. So nice and easy.
the selector and then pick the move random location instead.
Okay. Yes.
So, let's create the aforementioned task here to create the patrol path. So we're going to go to new task, BT task blueprint base, and we're going to name it.
Okay. Name it what?
I hit the key correctly. There we go. We're going to name it BT task underscore patrol.
Patrol. Okay.
And in that patrol, we're going to go to functions and
Functions.
add in.
On execute
override.
AI.
Oh, there we go. Override execute AI. There we go.
Okay.
And in here, we need to first of all get the patrol path and see whether or not it's valid or not. So the way we do that is go to controlled pawn, drag this out, and do get component by a class. And you want to choose the AI behavior component.
Wait,
and
by
for the
class.
first check, it's going to be checking whether or not this is valid. So does it have one? So
Wait, component or components? Okay, component.
Plug that in, like so. If it's not valid, we're going to finish execute.
Okay. If
But
not,
it's not going to be successful. It's going to fail. The next check is going to check the patrol path inside that behavior. So
interesting.
Get the patrol path, and we're going to check how long it is.
Oh wait, hold up. He's kind of flying through this patrol. Okay, so the patrol path. Wait, which one is it? Wait, what?
Check the patrol path inside that behavior. So we're going to get the patrol
AI
path.
behavior, which is right here. I keep doing it like that. Okay, so get. There it is. Get patrol path.
Path. And we're going to check how long it is. Okay, its size. So if you look for the map settings here, you'll see you've got length as an option. So click on that. And
map length.
We're going to say if this is greater than 0, then to another branch.
Okay, branch.
Again, if it's false, we want to finish execute.
If it's false,
failed it. That means we haven't got a patrol path assigned.
Finish execute. Okay. Oh, that's right,
So
because then it's going to shoot back to the other thing.
Patrol path assigned. So what I'm going to do is take this patrol path here, and I'm just going to promote it to a variable. So I've got it there. I can use. So promote to variable. Patrol path.
Okay.
Now, also in the variables, we also need to know what is the current path we're heading towards. So we go to variables, add new one, and do current
path.
Patrol index.
Oh.
And this will be an integer.
Okay.
And it's going to start at 0, so it goes to the very first point in our list.
Compile 0. Oh, right.
Speaking of which, we're going to make a new custom event to call it move to patrol point. And when we move to patrol point, we're going to drag out our patrol path.
Yes.
We're going to get the keys for it.
Keys.
And we're going to get a copy.
Get a copy.
And we're going to get the copy of the current patrol index. So if it's 0, you'll get the first one. If it's 1, you'll get the next one, and so on and so forth.
Okay. And
that'll return the actual actor of the patrol path in our world. So with this here, we're then going to tell our thing to do AI move to. And do that task there.
Okay.
Now it doesn't need to know who is the controlled pawn. So up top here, we've got controlled pawn coming from the execute AI. So we just controlled pawn here and just promote it to a variable.
Oh, promote it to a variable.
Plug that in. Makes it easier to hold of this. And so down here, pawn will be controlled pawn.
Wait, actually, wait. Did he? No, he didn't. Okay,
and so
I thought he used that.
Here, pawn will be controlled pawn.
Okay.
Next is the destination, and that's going to be the location of this patrol point. So get location.
Get location.
And put that.
Get actor location.
Acceptance radius.
Wait, get actor. Yeah, get actor location.
You can change this if you like, but keep it at 5. It's totally up to you what you want to do with that. And on success of this AI move to, actually let's do on fail first. On fail will be the same. It will just fail and finish execute, and then that. If it does succeed though, we want it to not finish the whole thing. We want it to wait for a certain amount of time.
Yes.
So on success here, we do set time by event. And from the event here, we're going to do create. Actually, it's just a custom event. It'll be fine. Custom event, and this would be on end waiting. Now, the time of this timer is going to be the control path.
Yeah, he's really flying through this. Jesus. Okay. Timer through to this is going to be the patrol path.
Get. Oh, no, sorry. Keys. Keys. And then get copy of the current patrol index, and then we want to find the value assigned.
Hold up. Get copy. Why didn't that work? Oh, patrol index. I used the wrong one. Jesus. Okay, getting a little spaghetti. Okay.
Yeah, so drag out from that map again, do find, and plug that into our get there. And this will return the amount of time we should be waiting here. So plug it into time, and the rest into keys. Now, when that time has finished, on end waiting will get called. And when it does end waiting, we're going to take the current patrol index here, and we're going to increase it by 1. So we're going to increment it like so.
Okay.
And when we do that, we're then going to call this function again, move to patrol point.
So move to?
There we go. So what we have to do now is go back to our execute here, and along the end, as we set patrol path, is we're going to call that move to patrol point.
Move to patrol point.
So we're getting the keys, finding which one we're currently working on, get that location, moving to that location.
Yes, and if it fails, it finishes execute switch to
location. It'll get the keys, find out how long it should wait there from the find, set a time for the waiting, and then when it ends waiting, increase the patrol index, and then move to the next patrol point, and so on and so forth. It'll keep doing that until it reaches the end. So this is what
you would want to do each time.
To the point where the patrol index is no longer valid because there is no more patrol points. So what we do is, before we take to move to patrol point, we are going to do current patrol index and check if this value here is valid. So let's drag out our patrol path.
So it's valid? Oh.
Get the length.
Okay.
And we want to see if this value here is greater than the length of this. So, if this value, so let's say our length is 1, the current patrol index starts at 0. We reach the end of that would be we reach the end of that first patrol point. That increases to 1 because of the increment. The length is still equal to 1, but we're no longer equal to it. We're greater than now. Won't work. So, sorry, I want to be greater than or equal to. Sorry, greater than or equal to. There we go. Yeah, if it's greater than or equal to, then we want to say, hey.
Okay. Greater than or equal.
We've reached the end. What do you want to do next? So, but if it's false, it'll just do the move to patrol point. Just carry on going. But if it's true, we want it to either loop back or end. So I'm going to set the continual loop by telling it the current patrol index here to be 0. So set patrol index here to 0. And then call move to patrol point again. And that means he'll just do a continuous loop around the entire thing.
Okay, that's okay. So it's simple as that. I'd say simple, but you gotta
save this.
Do it manually like this.
And we're going to go to the behavior tree. And on that selector here, we're going to do patrol.
Patrol.
And hit save.
Save.
Now let's take a look at this in game and see what it does. Now, for the purpose of this, by the way, for testing, I'm going to go to the AI controller and just turn off the target perception by disconnecting it. That works.
The target perception. Okay. Save.
Just watch him go around in circles. Okay, so it's going to go to each point, wait there for a certain amount of time.
So he's waiting. Boom. Now he should be going.
The problem is the time is set to 0. So if it is set to 0, that means he's just going to stay there forever.
Oh.
We need to actually tell him to ignore it if it is set to 0. So let's go to that BT task patrol again. And on this find here, we only want to do the set timer if this value here is greater than 0.
Is greater than 0. So take that off and just... Oh no, because we need a branch. Jesus, okay, so this is real spaghetti, but like this? Wait, where's the... Okay, so the greater Okay, so it's not plugged in, but it's plugged into the branch. Okay.
And put that there.
Yeah.
Actually, I'll tell you what would be actually a better way of doing this.
Oh no.
We're gonna take the find value.
Okay.
And I just want to make it a little bit above 0. Okay, so when I put in 0, I mean I want it to be just a little bit above 0, so it's almost the same as instant.
Okay.
So let's do a max value, so max float.
Max.
And we'll put in that find, and also we'll put in 0.1.
0.1.
So if the find value is 2 seconds, it'll choose 2 because 2
this is
higher
much
than
easier.
0.1. Put in 0, it'll pick 0.1 because it's higher than 0. So that way it's always going to pick a value. So test that again. That should give us a more elegant end there, like so.
Okay.
And you should go around the whole
Should
entire
wait
loop.
4 or 3 seconds here.
You can see him waiting for that certain amount of time for each
2,
step.
3. Boom. And he goes, and this one should be 10
And
seconds.
back to the beginning.
Or is it that one? Oh no, I guess I chose that one. And then it goes over here. Oh, this is
Now,
super
if we're on
sick.
a
That's
patrol
awesome.
route, and he sees us, then he'll leave that
Does it
patrol route
auto
and come
or
after
go
us
back?
because
Yeah, it
we've been
does.
set
Okay,
to
so he's
abort. So
now
to
does
test
it
out? I'm going to put the NPC
Oh.
back on the target perception here,
Oh,
and I'm just going to move my character to start a little bit further away.
interesting. So that's interesting because it was. Oh, actually, how did we go back? Wait, where is it? Oh, right here. Because he's trying to choose another path, but he's constrained to these areas. Oh no, my blueprint's messed up. Hold up. That's okay. Because we could just go here. Third person, maps, save. And there they are. I recommend doing that because that does cause other bugs to the stuff that you're using.
The
You did
target
that?
perception here,
Yes.
and I'm just going to move my character to start a little bit further away. Go over here. Play.
Okay.
Okay, and watch them go around, and then they see me, and they'll come after me and stop doing their route. And if I lose sight of them, they will eventually give up, go back, and redo their patrol route. Oh god,
Oh, yep. There they go. And they just found me, right?
just heard that.
Let's see. You should go. Yeah, I'm in the same spot
It's lost
too.
me now.
So he should be going because he waits there
It's
for
gone
10
back to
seconds.
that investigation spot to hit where that sound was. And now it's going back to the patrol route.
Oh, here he is. Awesome.
And there we go. We've now got a simple patrol pass system in our game.
I see. So the
allowing our AI
okay.
to
So
have
he
a
just
route
auto
for them to
picks.
take. However, we're going to add a little few extra pieces to this in the next episode, such as rotational and also actions they could do at those certain points as well. You can watch the next episode right now over on patreon.com/Ryan Laley. We can find all my videos early from just $1 a month. Thank you to all my patrons and YouTube members for your continued support. Make sure you're subscribed, and I'll see you all next time. Bye, everyone.
Hey, shouts out to him again. Super. Oh. So I thought there was just 6 videos or 6 parts, but there's actually a 7th. Getting back to where we left off last time, which was making patrol routes for our said AI, which is super sick, because next we're going to be continuing off of this, and then possibly finishing the series off with the next video after this one. But if we actually hit play, we could actually see, well, if he sees us, he'll follow us, but once he stops seeing us, then he starts, actually here, let me do this, so we can see him a little bit better. Then he starts going onto his patrol path, which he's going on right now, because he doesn't see us. Then he's waiting, and then he continues. And then he's going to, like, wait over there for 10 seconds, and then he's going to continue over here. Or no? There we go. And then it's going to be walking back. And then after it completes, it just goes where it goes into the walking movements around into the patrol circle. So it's interesting seeing the free roam being restricted to the patrol points. I wonder if there'd be a way to just make it just not have to focus on the tree or on like the patrol points and just focus on roaming. But that's something that we'll figure out at a certain time. But first, let's hop into this, shall we? So we can continue learning and get even better with the behavior trees in the AI part of Unreal.
Hello and welcome back to our AI series in Unreal Engine 5.
This is really huge too.
In this episode, we're going to work on our patrol path sequence again, this time introducing the outcomes, allowing us to change what happens when the AI reaches the end of the path.
Oh,
so there's some other little features that we can add to our patrol path
Okay,
points
awesome.
to add little extra nice little touches.
So this is what we're going to be working on.
So the last time we were here, we made this patrol path system.
Yes.
And our AI will follow it told to. However, we're going to add some last little features to this, such as when we make them actually look in a direction we've dictated via our patrol path points. We're going to change also their behaviour, what happens when they complete a loop. Do they want to continue the loop round, or ping pong back, or stand still? And also give the option to set some actions based upon these patrol path points.
So I probably do want to change them in different directions.
To actually just respond to the end of the loop. So when they get round to the end, what they're going to do. So currently, our patrol path is here, and when they reach the end, we are setting it back down to 0.
Oh, I've got to load it up. There we go.
And moving on. Now we only want to do this if the patroller is patrolling and wants it to do a complete loop and keep doing the loop. We're going to change that around. So let's make an enum for this. So let's create a blueprint enumeration. Sorry,
I was eating something. Okay, so blueprints, enumeration. Also, I had another Unreal dream that was about a mechanic that I thought was actually pretty good, but I remember it involved an enum or variable. But what are you gonna name this?
Patrol path outcome.
Patrol.
And we're gonna do
outcome.
First one here is gonna be
okay. Oh, boop, boop, boop. Get that up there. First one. So wait. Add. Okay, so add. That's right. So there it is.
Loop. And the description for this is going to be...
And then what?
Return to the first point.
Turn to... Oh, not even typing. Turn to the first point. Oh, so this is... Oh, then we have to know... Oh, we're making this.
Return.
The list of options for the AI to do stuff, right? Want it to loop? Do you want it to return?
Backwards. Okay. And
wait, return is traveling the route backwards. Why don't you just name that backwards then? That's interesting. Traveling the route backwards. What else is he gonna make?
And then we'll have another one for none.
None. Okay. Makes sense.
Still.
Oh, then why don't you just name that stand still? There's got to be a reason for that, right? Or is it just like, these are just the coding terms, so you want to, like, keep them like that? Because, like, in an engine like the gem editor, that's what they use here, but you could change it to be a different name. But we're going to be calling for this stuff later, so you got to remember that. But, of course, it'd be kind of easy to remember because it's loop. Loop is okay, but backwards and then stand or still. Or even say, like, stand still, but it's like if you want to make it like short, you don't have to. If you don't want the person to fully type this, but they're not going to fully type it because it's going to be one word, so they're just going to select it, right? I guess we'll see.
Save that. Okay, so think of the most efficient stuff. How we can use this. So our NPC currently is following this path.
Yes.
Now this path is being controlled by this AI behavior component that we made. So what we're going to do is we're going to edit this behavior task. So right click on that and edit AI behavior. And in the variables here, we're going to have the patrol.
That's right. Patrol
outcome.
F.
And that's going to be using our new enumerator.
Outcome.
So E. Patrol path outcome.
Cool.
And we're going to also make that editable.
Wait. Oh, hold up. No, it's this. So it's E underscore patrol path outcome. And we just select it. Awesome. This is actually getting good experience with using some enumerations in a different way.
I want to save that.
From when we learned them.
Okay, so
originally.
now let's go back to our patrol.
Yes.
And over here we are getting the patrol path quite easily from our setup over here, where we're getting the component by class and getting the patrol path. We also want to get the patrol path outcome from this. So just like how we've got the patrol path here and we're setting it over here variable, we similarly want to do the same thing for the patrol path outcome. So patrol path.
I guess we'll just move it, because this is where he's talking about. But we just kind of organize it a little bit different, because his valid should be like right here. I guess we'll do this.
Path.
Or what's he doing?
Get patrol path outcome.
Okay.
And I will promote that to a variable. So I've...
And then, okay, I see. So we'll keep it here then. Promote to variable. No, unplug. Boom. Boom.
Got
Okay.
it. Saved, ready for use. Over here. And over here is that when we end the waiting. So basically, this branch, when it hits true, this means that it has reached the end of the patrol path in its current state.
Okay.
So we're going to do a switch here based upon our outcome. So let's drag that out and do switch. And do switch on patrol path outcome. You'll see those 3 different options we made for our patrol path.
Oh,
so this one
that's cool.
we originally set up. This is the loop. So we're going to just drag that into loop.
Whoa, that's actually really cool. Okay. But still stand still. Okay, interesting, because now these seem like different type of stuff. So I'm a little confused. I don't know. We'll see.
And that's that one done.
I might be less confused just making them
now return,
I want.
Basically what it's going to do is going to tell it to go back in reverse order. So what we're going to have is another variable in our task here for direction. So I'll do path, direction. And this is going to be an integer. So I'm going to take my integer and compile that.
Direction.
And path direction, we're going to take that out and we're going to multiply this by -1. So if our path direction was 1, it's going to make it -1.
Which is going to go backwards?
If it is -1, it'll make it +1. We're going to set that back to path direction there.
Ooh, yeah, that's still so... That's nice. Or is... No, path... Return? Yeah, return.
And then we're going to move to patrol point.
And then plug in?
Okay, so path direction is now
sets the direction.
Value. Yes. When it goes back to move to patrol point. Oh, hold on. We need to, before we do that, we need to tell the current patrol index. Set that.
Okay.
But actually, I think we can actually leave that out. Actually, I think we can just do with just this. Yeah, so the path direction multiplied by -1 will just flip it around and it'll go around and continue moving to the patrol point. Now, we need to use this direction over when we do patrol path index. And patrol path index is adding by using this increment here. I want to change this. So rather than just adding like that, we're going to do the addition node itself.
Okay.
Plug that in. And then set that to current patrol path index.
Path index. Okay. I see.
And we're going to put in the path direction. Now, path direction will make sure the default for this is 1. So it
got to compile a save. Is 1. Okay.
It increases by 1. We put it into this addition here. So if it's 1 and we're going forwards, it'll just keep incrementing like normal. But if it's -1, because we've reached the end already and it's turning around, the path direction should be -1, and if that makes it'll make it smaller, and it'll keep going and going and going until it is no longer valid. Now at the moment we're just doing a check for length. We want.
Oh wait, Oh, I see. I'm doing it wrong. Hold up. Okay, so I got to. Oh no, it's both. So I just got to plug in here. There we
I'm
go.
going to change that to a check of validity. So I'm going to change that from length there, and we're going to do keys. And is valid index. And I'm just going to make this a little function for us. I'm going to right click on this and collapse the function.
Got the function.
Call this one as is valid map.
Oh no, wait. He also included the other one, right?
And I'm just going to make this a little function for us.
Oh no, he did the whole thing. Okay, so boom. Okay, so do that. Do this, and then collapse the function. That's pretty nice.
And collapse the function.
When you don't know when you're going to be using functions, you could build it all out first.
Map index. And I'll make this a pure function.
Is
open it up.
Hold up. Is valid. Crap, what was it? Map index? Yes. Map index. And then pure. Okay.
And inside our valid map index, we're just going to plug this map index, this valid index over here as a pin for the index to test. Now we're not outputting the patrol path, we just want to output the boolean, so plug that in there, and we'll just clear the output there. So it just looks pretty simple. We get the patrol path, get its keys, check if it's a valid index, and outputting true or false. And because it's a pure function, it'll get it right there and then as the most accurate timing it can be. So is valid map index would go into our current path index there.
Okay. Super spaghetti, but okay. Understanding step by step. And then we remove that too. Okay, so this is gone.
And that will go into our branch. And because that is doing basically the opposite of what we had before, we want to swap true and false around here. So false, I'm into true there.
False goes into true. This is pretty overwhelming, but we're taking it. We're understanding it step by step.
The way around, true goes into false. Move that down, like so. Okay. So when we end up waiting for a move on to the next point, we're getting the current point, adding on whatever the path direction is to the new current patrol index. Checking whether it's a valid index. If it is, great, move to it. If it's not, now it means we've reached the end of some description, either the very end or the very beginning if we're going in reverse, and then it's going to flip round and do these various things. And if it's set to none, we're basically going to do nothing. Okay, so here we're gonna...
Now hold up, did I see that? Did he... Oh no, it's still patrol. Okay, so that's still there. I thought I didn't see that.
Or the very beginning if we're going in reverse, and then it's going to flip round and do these various things.
Right. Then what we're doing for none,
we're basically going to do nothing. Okay.
What?
So here we're going to tell it to basically stand still. Now,
I thought you were like not doing anything. Like, how's that going to work like that?
And then keep going round and round and round.
Yeah.
We want it to finish this execute here. And we're going to put that down here.
Oh, so it's just going to keep them. Oh, so it's just like that.
Save.
Okay.
So on second thought, we actually do need to put in our new current patrol index over here, because we've changed it once already here already, increasing it beyond the valid index, and this is going to, we want to make sure we set it back to its non-valid index. So what I'm going to do here is just basically copy this again, and put this over here,
and then paste
after path direction's been changed.
Nice.
Okay, so with all that done, we should be able to go in here and test this out. So we've got our character set up here to return. So it should go around the loop to the end one, which is...
Wait, character setup, hold up. Wait, where? So AI behavior. Wait, where's this? Wait, AI behavior. He's an all. Okay, he compiles.
Also make that editable.
Oh, that's what it is. I knew it. Okay, instance edible. There it is. I knew it. It was that button. I knew it was that button, but I didn't know where to find it. We found it.
You do need to
Awesome. So let's get back to where we were,
It's over the same path back.
which is here. Awesome. Okay. Nice. So, boop. We can make him loop and do all that stuff.
Okay, so let's watch him do this.
So this is going to be a loop.
So here he comes.
Or wait, it's... Okay, wait. Now that's a thing. Wait, doesn't it like see up here somewhere? Hold up. We'll just do this. And then tilde. F4. So he's he's doing a return? Yeah, he is. So he returned. Like he went backwards, but then he completed it. But is that because he's found the arrows? No. Okay. So now he's going the right way around. Hold up, let me do that again. So he goes over here, right? And then he hits the end. And it's like completed. Okay, then let's go the other way. So if he was put over there, he would walk. I'm gonna do this. So if he's over there. Oh no, he saw me this time. Oh. F9. Oh. But that's not backwards. Is it not working? Blueprint. Return. Let me do none. I feel like this is the behavior tree issue. But he hasn't shown anything. We haven't changed anything. I guess maybe we have something messed up from the last one? Okay, let's see what it's supposed to look like. Okay.
Gets to here, the end point. And now he's going to go back the way he came. Yeah. And you do the same stuff each way. No, it's just going in a different direction. As we reach back to the beginning, he's now going to bounce back and continue going round. So let's check out the other ones, make sure that they're working okay. So we're going to change that to loop.
Interesting. Okay, so for
loop,
loop,
that should be what we had before, where it gets to the end and just goes back to the first point. A continuous loop.
okay.
And it should go down here. There you are.
I want to see. Okay, so does he just loop?
And then finally we've got stop.
Yeah, I feel like he just
does
looped.
Nothing, or none rather. But he should just get to
Okay,
the
so
end.
is his going to bug out?
Shouldn't do any more.
No, his is bugging out.
Actually, no, that's not accurate. I know exactly what's going to happen. It's going to just keep looping around. That's my theory out. I'll explain why that theory is the case.
Okay. Interesting, but this guy's
So
going...
we can continue around. And
Wait, did I loop?
The reason
No, I did
why I
return.
can do it again. See, here's the error.
Yeah?
The task patrol here, when we do finish execute, basically
Wait, where? Okay.
the behavior tree then is going to leave this and move on.
A behavior tree. Selector. Yeah. That's so weird. Okay.
But if it comes down to here,
Yeah.
again, all those values that we've set up in here are reset, including the path index. So we don't want it to finish execute. We just don't want it to do anything. So if you
Okay.
leave that as none, as nothing, not attached to anything, it will just get stuck
really?
inside
Okay.
this BT task patrol. And you can leave it like that, really. Should we just
Oh, wait,
test
hold
that
up.
out again? Set to none.
Yes.
So he should just stop when he gets here, because he's got nothing else to do. He'll just keep getting stuck there.
Nope. Mine's continuing to... Oh, wait, is he? He's going to. Unless they finish the path.
There you go. Okay,
But
so
wait, if my
that
guy
is
was
our
on the...
patrol
Wait.
path outcomes added in. I now want him to do something different at each of these patrol paths. So
Hold up.
with these,
It's on 10 seconds. He's doing normal... Wait, what? And he's just going to keep going. I'm just making sure... does he stop at all? No, he does. But he... Wait. What? So I guess it has to finish the whole thing. But if he starts over there... Wait, what? Actually, I don't know, because, like, wait, no, he started over there, but he... I feel like he did a circle and then went on track. Like, in comparison to what I thought it was gonna do. No, why did it just do that? Is it because it's following the arrows? No. Bro, this is... Okay, I feel like it's the behavior tree. We at least know that there's an issue over here.
All those values that we've set up in here are reset, including the path index. So we don't want it to finish execute. We just don't want it to do anything. So if you leave that as none, as nothing, not attached to anything, it will just get stuck inside this BT task patrol. And you can leave it like that, really. Should we just test that out again? It's set to none. So you should just stop when he gets here, because he's got nothing else to do. He'll just keep getting stuck there. There you go. Okay, so that is our patrol path outcomes added in. I now want them to do something different at each of these patrol paths. So with these path points, we've got these arrows on them dictating which way we want him to ideally face. So what I'm going to do is make it so that when he enters this area and stops at it, we want it to trigger and say,
So
hey,
I'm going to change it.
do your thing. Now, not when as soon as he enters, I want him to wait till
Because he already does the same thing over and over.
So we're going to work in combination of what we've got here for our patrol path index, patrol path point, sorry, and our patrol path task.
Okay.
So our patrol paths here need to have an idea of when they should do this. So we're going to go into our patrol path here, and we're going to have a custom event in it.
Oh.
Called
Add custom on
patroller entered. So when the patroller's entered that patrol path point and is ready to do its thing, it will call this. Now, right now, we're going to leave it blank. I'll come back to that in a second. Now let's go over to our BT task patrol. So on patrol, we've got when he reaches the location and keys here is when we set a timer to end waiting. Now alongside setting the timer, we also want to tell our get here, reference to it, to call that event we just made. So we're going to do on patroller entered.
On... Wait, what is it? On what entered? Oh, patroller. I thought you said controller. Wait, then I spelt it wrong then. Which is, I think, messing me up. Hold up. Which one did he go to?
On patroller entered.
Let me do that. On... Oh. Mini player? Is it this? No. Wait. I'm so bad when this stuff...
So want...
Okay, so
on patrol a second. It'll call
That's right. So we went here. Right. And we want that. So then we go here.
Right now, the task made. So,
and then we go here.
I'll get here.
Okay, that is the right one. I was like, wait, is that the right one? Yeah, that's all right. So get... Oh. Or on... Patrol entered. There it is. Okay.
Here, reference to it, to call that event we just made. So we're going to do on patroller entered.
And then hook that up? Okay.
And now our patrol point can have extra code in it to run different things.
Right.
So let's take a look at that. We're going to go into our patrol point, and I want to make him first of all turn and rotate around to face the same way as the arrow. Now currently our character is turning and rotating based upon their control rotation. So if we go to their character, which is here, you can see on the character movement we've set up the rotation settings to rotate using the controller desired rotation.
Yeah.
So theoretically all we have to do is change the control rotation to match what I want him to do.
Oh, so that's what we're doing this?
In our patrol path point, I can get our controller, and
Yes.
I want to actually know which controller is going to be doing it. So what I'm actually going to do on this control entered is add an input to this to know who it is. I'm going to change that to a character.
Okay, character.
Put in a character. That. Now when I compile this to a character.
Character what? Oh, just character. Okay, so. Character. Okay. And the name.
Character. That. Now when I compile this will be fine, but the beta
Okay.
task patrol now will have a blank character pin on it.
Yes.
And that is going to be our controlled pawn. I'm going to get
Controlled
that out,
pawn.
and we want to drag this into that pin, but we can't because it is a pawn, not a character. So from the controlled pawn here, we're going to cut us to a character. And I'll make that a pure cast.
Cast to character?
And there we go. But now if I go back to my patrol path point, I now...
Hold up. Pure cast. That's right. Pure cast. And then we're going back in here?
Who it is we're dealing with.
okay.
And what we'll do here is I'm going to take out this character, get the controller.
Get controller?
And I want to set the control rotation of that controller.
Oh. Yes.
To the rotation of our arrow here. So drag out the arrow, get world rotation, and plug that into new rotation.
Rotation. Okay.
So let's test
Makes
this out. What I'm
sense,
also doing here
but
is
still
print
is pretty
string,
complicated, it seems.
indicate when we've met. I'll just say hello.
In the sense of a lot of steps.
So if I go into the game, push play,
But when it plays...
hello there. Hello,
Okay.
but he's not turning by the looks of it. So let's take a look at what's going wrong here. Oh, actually, it could be. I don't know.
Oh? Wait, what did I do wrong? Oh, wait, what? Did I, Wait. Tried to read property. Read K2 node event. Node set control rotation graph. Access none. Trying to read property. Accessed none when try to read property. Did I do that right? Control pawn. Is that the issue? Am I missing these little things? Oh. Wait, is he? Hold up. No, I don't think he's printing string. But it's not erroring now. But if we go back to here, so that's right. Okay, so then it's target, character. I see. Let me just make sure that I got this right to, I guess, confirm that it is a issue for the back.
And there we go.
Yeah, because I didn't do that. But I did it now.
Okay. Now if I go back to my
And then go back to
point,
here.
I now have access to who.
And then that's right, because we do all the controller stuff. Get controller, set control
So
rotation,
let's test.
and then print string. Just to make sure. No, so I'm not going to print string because it'll be on the top left-hand corner. So this is not being set by timer. So this is an issue. Oh man, I want to. Okay, because I can figure this out. I know I can, but I don't want to spend tons of time trying to do so, and like bulk this up. Okay. Oh man, but this is kind of an issue.
Test this out. And what I'm also doing here, do a print string, indicate when. But he's not turning by the looks of it. So let's take a look at what's going wrong here. Oh, actually, it could be. I don't know. I'm going to make it a bit obvious. I'm going to turn this one round. Wait. Okay. So let's see that in action. See if that does turn around. Or if we've got an issue. Nope, we've got an issue. Okay, so his control rotation is not turning him around. The only reason that would be the case would be that there's something else controlling his control rotation. So we need to take a look at that and break that down. So because the control rotation is being adjusted by something else, we can't really use it. So what we're going to do instead is on patrol entered is I'm going to turn it around using the tick event and using a lerp. So I'm going to take the tick and put in a gate. And this gate is going to be opened by our patrol entered.
Okay.
On the exit of this, we are going to make him rotate to face the same rotation of the arrow over a lerp. And because it's on a tick, it will lerp smoothly.
I mean, we gotta do this anyways.
R-interp 2. And we're going to take...
Whoa. What is that? R-interpolate, okay. R-interpolate 2.
The target value is the arrow's world rotation. We'll plug that in there. Then the current is going to be the characters. So we're going to get that reference there. And in fact, actually, let's promote this reference here whilst we're here. Now, promoting it because I want to make sure I get a clean reference and that reference doesn't get lost each time. So I'm going to put that in there.
Interesting.
And I'm going to get the character.
I don't think this is fully going to fix our issues.
And get their actor rotation.
Get actor
put that into current.
Rotation.
Delta time. Could be delta seconds here. Or you can do world delta seconds, whichever way you want to do. Interrupt speeds, how fast they're going to turn. So we'll do it as 2 for now. And then we're going to set that back to the character's rotation. So character, set actor rotation. And plug that in. Now that's going to open up this gate, but it's not.
And then plug this in.
Okay. Close the gate. We do want to actually close that eventually. We don't want to keep it open the whole entire time. So what we're going to do is make something that does on patrol exit to close it. So let's do a custom event.
Interesting.
On controller exit. And that's going to go into the close of that gate. I'll save that.
And then we're going to call controller
print string in
exit
to our thing so we know what's going on. In fact, actually, I'm going to do that on the sequence here. Hang on. Let's just move this up. And I'll put this into a sequence so the character gets set, then it goes into a sequence.
Press S and then left click.
And then 0 will go into the open, and then 1 will go into our print string.
Wait, hold up.
There we go.
So one's going... Okay, so exit close. This is going over here. This is going through. 0's going to open, and 1's going to print string. This is for testing purposes, but I'm going to do this too.
Okay, so if I now look at this now, we're going to go through a gate event, and in here we're going to tell the character to slowly lerp the rotation towards the arrow over time. And when it's exiting, we want it to call our on patrol exit. So this thing we need to call, and we'll do that on our PT task patrol. And what we're going to do is do that on the end waiting here. So when the end waiting is finished, we're going to call that thing. Now on here, we want to get access to this reference here. So it might be actually worthwhile promoting this get here to a variable and do this current.
Okay. A lot of steps here. He does all the steps and then explains after. I do prefer when it's explained as we go on, but I guess we'll see how this fully works here, or like, yeah, how it fully works in a way of an explanation.
Front point. Control point. We'll do that.
Current patrol
Rather than
point.
dragging lines everywhere and managing.
Wait. Every time I do that, I look away for a second, then he unplugs and plugs.
Rather than dragging lines everywhere and managing that all over and over again, I just get a patrol point and just drag that out. Now I can save myself a little bit of lineage. I can just put that in there instead. And now I don't have a line going right across. And on the end waiting here, I want to move all this along.
Jeez.
So all this, and move it along. And I'm going to tell my current patrol point that I'm exiting. So on patroller, exit.
Current control point. And then on exit. Oh wait, hold up. Wait. Oh, controller exit. Wait, what? Did I name it wrong? Wait.
Waiting.
I guess I did name it wrong. Wait. Oh, but why are we calling that?
Learn. And then I'm gonna go for. That's it. That's it.
Oh, I guess I did.
Yeah. Okay, so
I keep thinking he's saying controller. Wait, on patroller. Patroller, not controller. So on patroller. Exit. Which, while I'm here, I should fix this. Easy that we could just fix this and it doesn't fully recompile everything. And then compile save. Go back on patrol exited. Yes, okay, here we go.
This now we're going to go through a gate event, and in here we're going to tell the character to slowly.
Wait,
and when it's exiting, we want it to call our on patrol exit.
No, he's doing it now. Okay.
When end waiting's finished, we're going to call that thing. Patrol.
Boom. Go forward a little bit. Going forward.
Yeah. And now I don't have a line going right across. And on the end waiting here, I want to move all this along.
Yes.
All this, and move it along. And I'm going to tell my current patrol point that I'm exiting.
Yes. Now we're going to move this up.
Exit.
And then go across. Yes.
So let's take a look at
save.
That in action. So
save.
It comes in. You see that slow turn, he turns around. This one should be more obvious.
Oh, it works.
Turn it back around like that.
That's working.
With those points there.
It's just the other stuff is what's messed up.
And there we have it. Now, because we have those patrol enters and exits as well, we can also do other things like special events or triggers or whatever you want as well. So if you go into the patrol path point,
right,
you can add anything to this sequence here after this print string, or instead of this print string, to do anything. Now, to make this really useful for level blueprints and for animations and anything like that, we're going to go into the event dispatcher, and we're going to do on point met, and we're going to drag that out and call that on point met. So if I've got a specific event I want to happen at a certain point in the game, so something like when he enters this point, I want an explosion to go off or something, I can easily do that now because I can just select the patrol point, go into the level blueprint.
Wait, select the control point. How did he... Okay, yeah, he's flying through this.
Easily do that now because I can just select the patrol point.
Yes.
Go into the level blueprint, and then I can right click and add an event.
Right click.
Default, and there's my on point met.
Right click, add an event, default. Okay.
And that means that will trigger when this gets called.
I see. Okay, so that would have to be... So then this would be play animation montage. So if you're making it where it's like set up in the room and there's some objects and you want them to go over and investigate that object or like just interact with it over here and so wait, where was it? Yes, here it is. So on the patrol path point, but wait, okay, so this is going to get called. So you're going to have to make something that chooses whether it's called or not here, though. Since he's not giving us that, because it's going to go in sequence. This is both going to fire, right? Because it's, yeah, executes a series of pins in order. So 0, 1, 2, 3, 4. Now, you're going to have to make a maybe so a branch here, so a boolean. Then within that, we go to the level blueprint, and we put the animation montage here, because that's going to fire when we want to do that there, which is interesting because you have to think because you have to start thinking in those ways. And this is so huge because coding and just like game building and the whole type of structure is all the same, and it hasn't really changed that much. It's just the ability to do things is much faster. So for like understanding this, it's like, okay, so I want this person to go to a sink, or like a Sims game, right? I want it to kind of automatically go and do like Sims type of thing where it's got that type of stuff. Okay, then this would be something that we would use. It would be here, and we could even do overrides, but you wouldn't really want to do overrides here. This would just be the AI path point. Well, this is the level blueprint, so there would be multiple things here most likely. So this would be added on, and then it would be commented, and probably saying like this is the, the patrol path stuff, so it's easier to see. And then you have your other control paths here, so like copy paste, which I copy paste now. This is a custom event, so it shows it like that, which is pretty cool. And that fires the other animation. So when you get next to the sink, because we could set its. Where is it? So we go into character. We could set the times. Go to AI behavior. Patrol path. We could set the times there. Patrol path outcome none. This is still messed up, but ideally we would want them to loop for like that type of like Sims thing. And then it's like, okay, wait 10 seconds at the sink, and then the animation is 10 seconds. So you probably would want to like have this set to the animation length, so it stops and goes when the animation plays, making it look like the animation is triggering, like the person is actually walking up and cleaning their hands versus not.
Okay, so you can do some pretty neat things with that.
Oh.
And there you go, we've now got our patrol paths pretty much done. I'm quite happy with how they've turned out, and by all means you can use those different events and different functions to call all sorts of crazy things to happen, so it's really quite flexible. In the next episode, we're going to go through and look at another sense on our perception system and look at the touch sense. So if you want to watch that episode right now, head over to patreon.com/RyanLaley, where all my videos are early for all patrons, donating just $1 a month. Thank you to all my patrons and YouTube members for the continued support.
Respect.
Make sure you subscribe, and I'll see you next time. Bye, everyone.
Oh, heck yeah, shouts out. You know what? Let's actually get right into it. Here we go.
Hello everyone, and welcome back to our AI series in Unreal Engine 5, and in particular 5.1, because the next feature...
So for the issues that I do have for my stuff, I know I'll just have to go back in the earlier videos and legit just like skip every few seconds and just see what I missed and what I didn't click for like a setting or something like that, and then that'll be fixed for my issue. But since everything is kind of working besides the actual path outcomes, that's okay. I mean, of course, it's not the best, but it's okay.
Is a 5.1 exclusive, and that is the touch event.
Yes.
Previously, the touch event was basically exclusive for the C++ version of the engine. In this episode, though, we're going to show you the new blueprint version they've added in 5.1.
It was only in C++.
Now, if you haven't got 5.1 installed for your game and you want to use the touch event, there are workarounds to creating something similar to this, which we'll go through in another video later on in the series. So let's get started.
Okay,
let's take a look at another one of those senses. Let's take a look at the touch event. Now, the touch event is something that happens when you bump into, or something bumps into your AI. So there's a couple of things you need to make sure you're aware of when you are enabling this. So first of all, let's go into our AI's setup and go into their controller. And in their controller, we've got the target perception.
So, wait, controller? Yeah, AI NPC. It just says AI NPC, so I don't think if it's a controller for whatever reason.
Updated here. We've turned it off while we're working on patrolling. I'm going to turn it back on.
Oh. Oh, maybe that's... Wait, what? Is that the reason? Oh, that's the reason why he kept chasing us. Wait, if that's on stop, why did he go here first? You know what I mean? Like, what is going on there? That's so weird. Okay, whatever.
A second. But before we do that, we're going to go to our AI perception component, and on the right hand side we've got the sight config, we've got the hearing config.
Yes.
We're going to add another one for the touch config.
Okay.
Touch config is pretty simple. There's very
Touch
little
config.
to really change on it. You just want to enable it really. And that's all. And we're going to leave
Max
that alone.
age.
Now if I hit compile and save that, what that's going to do is when I bump into them and they have a hit event associated,
Yes.
we're going to have this target perception updated, trigger it. Now, at the moment, we're handling sight senses, handling sound senses. Let's make it also handle a touch event. So let's go into making handle touch.
Oh. So new function. Okay, so handle touch event or sense.
Event. Now, much like how we've got the
Node
handle
event.
sight and handle sound, we want to make sure we're passing through the actor and stimulus into this. So
Okay.
let's make sure we add that to it.
So
And we
actor.
do actor, which is an actor reference. That's into there. And we also want the stimulus. So let's do stimulus.
Actor and then object reference.
And we'll change
And it didn't work. Actor. Object reference.
that.
And the next
to
one?
A stimulus. Struct.
Dim.
Yeah, stimulus. Yeah. Okay, and yep, very much like the same as the sight and sound. We're going to get the class and then
And then it's AI, right? Yes. So I just click. There we go. Okay, cool.
we're going to check if it's equal.
Oh, then also rename stimulus. I want to make sure that's. Wait, is that the same? Yes, it is. Make it short.
Equal to the one we want.
Okay.
So we're actually just going to copy this.
And okay. Wait, is he in the right one? He's in the handle site. I mean, which is same stuff. It's legit same stuff. I just want to make
Copy
sure.
point and just
Boom.
paste it in here
And then paste.
and plug that into
And the
stimulus
connect.
there. But changing the sight sense here, AI sense to touch. Okay. And
Touch.
now it'll go off and do their true. Now the thing I want them to do
And it's just AI sense touch, not the config.
is I want them to respond to being touched, to chase after and look for me. Now,
Yes.
which is very much similar to this sight sense. So if I go to the sight sense, we're going to have a very similar setup here where we do the actor is equal to player character, and then checking and doing all this other stuff, make sure that all works.
So
Now,
just copy and
I'm
paste.
going to take this part here and the branch, and all of this bit where we change the target actor.
Okay.
Stimulus, and I need everything basically except for the last known location. We'll leave that alone, and I'm going to copy that and put that
Copy.
into my handle touch event.
I love
It
it.
works basically the same, so we can leave that alone. We've got
Oh,
return
I love
node
it.
in the false. I've got another one in that false as well, and I
False.
think we're good. Okay, so that is all we need
Dude,
to
I
do
love the copy
here.
and paste stuff.
Now, if I hit compile and save this, I'm going to go into my event graph, and I might have got sight and sound here. I'm just, for testing purposes, going to not plug those ones in. I'm just going to plug in the touch event and
Okay.
plug that in accordingly. So, okay, so in our touch event, to make this work,
Yes.
we need to check to report a touch event. With that done, we now need to set up the
So-
reporting of the touch event. Now, go into your NPC, and we're going to add the
Yes.
event hit, which is an event that triggers.
Wait, on event. Wait. NPC. On. Event hit. Or event hit?
When anything bumps into
Okay.
the character.
Interesting. Okay.
And we're going to
event
do
hit.
report touch.
So. Touch events. Okay. Interesting. So event hit could work in different ways too.
Event. Now, report touch event only exists in engine version 5.1 and higher.
Hey,
If you're in anything
let's
lower than
go.
that, this does not work, and you won't be able to do this in Blueprint. It's only a C++ thing, which is really annoying. But hey ho, that's what they did. But here we've got report touch event in 5.1 now, finally, so we can use this. Now on here we've got touch receiver and other actor and location. The other actor is this other here. The touch receiver is going to be self, and the location is going to be the hit location. We'll just plug that in there, and that is it. Hit compile and save that. So now if I go to play the game and look at our character and go to debug and do that again.
I don't. Yeah, I see that doesn't have to the
so
site.
There's our scene one. The
What he
blue
does
one
for
that
him,
you
but
will
not
see in
for
a
mine.
second is the touch event.
And then boom.
There's a touch event.
Oh
Now
no, I
he's
forgot to turn that
coming
on.
after us because that target actor has been set.
Hold up. Okay, so boom.
Okay.
Never mind. That's right. I forgot to turn that on. And then there it is. So if you put the age to 1,
And that
it
is the touch event.
won't, or if you put it to like 2 or 1, it won't start attacking you unless it's at that number. So where would we go to change this real quick? I'm so, memory's bad right now. Crap, I can't remember. Oh no. Crap, I can't remember, but you would change that there. Oh wait. We would okay, so we just did so much across so many different things, and that's the confusing part here. Is that we literally did so much like that. I think this is probably the most we've done this much type of like across multi type of files and stuff. That it's like, I feel like I just want to, you know, like I'm used to just sticking in like 2 trees, so it's like, okay, boom, 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 boom. I cannot remember for the life of me. It's in one of these windows. I know it is. Would it be the site sense stuff? It might be. Either way, here, I'll continue this.
And there you go. We've now got the touch event, nice and simple, into our game. In the next episode, we're going to go through and take a look at the perception event. This is a different type of a stimulus made by the perception system, and I can't wait to show you what you can do with it. If you want to watch the next episode right now, head to patreon.com/Ryan Laley, where you can find all my videos early from just $1 a month. Thank you for watching. Make sure you subscribe, and I'll see you all next time. Bye, everyone.
Huge help, huge help. I don't know if that is available yet. Let me just double check. What team? Oh no, there is. Okay, so there is another part. Prediction sense. Interesting.
Hello everyone, and welcome back to our AI series. We're going to continue looking at the AI perception system, in particular looking at the prediction sense, about how it works and how we can use it.
Let's get in, shall we?
So let's jump in and get started.
Oh, this is awesome.
So before we put in our prediction sense, let's talk about what is the actual problem it's solving. So the issue that we have when we lose sight of our character, they are going to just head towards our last known location, which is basically just the last location they saw us in. But if we're moving, it doesn't take into account which way we're actually going and try to cleverly figure out. Like, for example, this pole here, if I run to this other side, he's just going to keep running around that side, even though he knows that I would have gone this side. So we want him to predict that I've gone around to the other side of the pole.
So, okay, so we're literally, okay.
So we're going to do that by going into the AI's controller and going to the AI perception.
Okay, AI controller? And then AI perception. So I guess that's the darker and darker AI. I guess their prediction sense was just too much. Oh, then also something I heard about darker and darker. It got delisted from Steam because of DMCA. So they used the assets that their last dev team made, and that's for sure because I guess they got in trouble for it. I wonder if they're going to get, if they have to give the money that they've made to the people or not.
I'm going to go and add another perception to this. That's going to be the perception sense config. So on the handle site sense,
you mean prediction? Yeah, prediction sense config. Okay.
Go over to where we at the end are setting it to false.
Hold up. Which one is he in? Oh, handle site sense. Boom.
and getting the last known location.
Yes.
Instead of just blindly setting this up as the location, we're going to do a prediction. So type in the word prediction, and you should see the request for a pawn prediction event.
Ooh.
Click on this, and we'll plug that into false there.
Okay.
Now the predicted actor
Plugging into false. Okay.
and the requester are pretty simple to fill out. The requester is itself, so that would be the currently controlled pawn. Get controlled pawn. And the predicted actor is who we're currently looking for. In this case, they're looking for the player character, so we could just check it against the player character. We're going to put that in there, and put that
Copy, paste.
And the prediction time is how long is it going to predict it for. Now, the way the prediction works is going to look at the velocity of the character, look at their current speed and direction, and over time, to work out where they think it will be in that certain time frame. So in 2 seconds, where will they be? So you want to ideally keep this prediction time quite small. So I'm going to do 1 or 2 seconds. We'll do 2. Okay. And we'll hit compile and save that. Now, part of that is I don't want to use the last known location now at the end here. So I'm going to disconnect that for now. And we're going to make a new handle event for handling predictions. So for this, I'm going to take the handle sound sense. I'm going to duplicate that.
Oh.
And do handle.
I haven't done this before. Just duplicating.
Prediction.
Handle.
And in here, we're going to change the class here to prediction. So AI sense.
Then here. I need to get used to doing like that stuff. Not just only in blueprints, but like everywhere in Unreal. And then prediction. AI prediction. Sense, right? Underscore. No config.
Prediction. And then no config. On here, make literal name, we're going to change this to, rather than target location, to that last known location. Okay. So let's go back to handle site sense.
Oh, and just copy and paste.
Text there.
Well, okay, so I see. Okay, well, I guess I'll get in behavior that as well. So this would be prediction, site sense. It gives you the whole word, but I also Control A, which is select all. That's a keybind that's like universal in Windows, and then Control C for copy, and then Control V for paste. And put that into my prediction function there. Okay, so I hit compile and save that. So now I can go back to my event graph and I can add this in to handle perception. Oh, okay, so he's got it lined up. Boom. Boom.
Prediction and plug in the stimulus.
Right. That's actually pretty simple in this way.
So let's now see that in
it's all pretty simple, but it's just like, of course, you add a lot of steps to that, then it gets pretty complicated on remembering every step.
If I go ahead to the character and go into debug and turn on the perception debug.
Yes.
When you lose sight of me, you'll see. Hold on.
He doesn't see us.
You'll see there's been a track.
But he heard us?
See where I've gone. Okay, over there. So he's taken that prediction in 2 seconds. I'd reach that distance. So you can see what I mean by the time frame being too long or too short can be a big problem. So in here, I feel like 2 seconds might be too long. So I can run around this way. You can see he's predicted that I'm going to head over there.
See.
And he's going to head over to that direction. As he hears me or sees me before then. Okay.
Interesting.
So that works pretty well. So I'm going to turn it down from 2 seconds down to 1 second, I think.
Okay, so the prediction. Interesting. So that definitely is what the Dark and Darker AI, I think, was having to think. I think the prediction was just a little too high. At least well, no. They put a lot of mobs into, like, one room. I mean, I understand why, but I felt like that was such an early concept of what something could have been better fully fleshed out, especially with the AI and everything, with, like, these numbers.
So we go back to...
And then go to handle prediction? Wait. Okay, gotta look back. Hold up. Where did it go?
Okay. So that works pretty well.
Oh,
so
what?
I'm going to turn it down from 2 seconds down to 1 second, I think.
Oh, that's what. Okay, that's another thing is doing that, because that's right. Because these are functions, so we could just double click and we get into these.
Go back to site sense and change the prediction time here down to 1 second. That should bring.
And then, okay, so it's in our sight sense. Sight sense.
Getting a bit tighter.
This we just
old
delete?
code now.
Okay.
And take a look at that in action. So,
Boom.
in prediction
Boom.
mode, and he predicted I'm on this side of the pole. So, and
He
Now
actually
try
touched
to
the
work
corner and it made a touch box. That's hilarious.
his rotation's a bit messed up.
Ooh.
But we can have a look at that in a minute.
It's working. This is cool. This is really
So
cool.
he's seeing me and coming after me. And he loses sight of me.
And if I
Going to the
jump,
old location, which is an issue. We don't want him to do
the
that.
jump, that's
We
bugged
want him to
out.
go to the new
He doesn't
location.
immediately go to the sound.
Let's have a look and see what the cause of
When
that
I
is.
jump.
So if I again go...
Oh, is it because of the range?
Right here. Yeah, he's going to the old new
Might be.
prediction, which is not exactly what we want, obviously. So let's just do that again. Yeah, he's going over to an old one. So let's work out why that's doing that. So let's go into our behavior tree and look at the flow of information that's happening here. So it's coming into selector, target actor is set, and going down here, target location, which is not set, not moving to target location, it's just going towards the target actor. So that'll be over here. So chasing, target actor is set. So when that is changed, it's going to abort both of these. So it's going to come out of target actor and go back up and not do this one either. It's going to go up, okay? But it's going to then go to move to last known location. So that move to last known location is being set after the break has happened. So here we change the target actor to nothing. It's breaking out and it's doing the move to based upon that information. Now what I can do here is I can click on this observe blackboard value, turn that on, and leave it like that. So now it'll observe this last known location and it should hopefully update because the tolerance here is only 4.75, which is tiny.
Right.
So big difference should make a big change there and it should make it move to the new last known location.
What does tolerance do?
So let's take a look at that in action and see if that is the case. So I'm going to go over here. There's last known location is there now. And he went to it. But if I get seen, break last known location, and he's now coming to the new last known location. Exactly what we want. Okay? So he's going to do that. And there we go.
I think he's doing that.
Excuse me again.
Oh no, he's going to the hearing position.
That's working really well.
Oh no, yes, it is working now. Yes, it's. I see what he's talking about. So now it's actually going to the position.
We've now got our prediction sense in our game, showing our AI able to predict where we're going to be in the future.
Yes.
So in the next episode, we're going to start taking a look at the EQS system. This system's quite involved, has lots of stuff in it, so I can't wait to get started with it by showing you the basics of how to get started with generating different items inside your EQS system.
Interesting.
So right now over on patreon.com/Ryan Laley, you can find all my videos early from just $1 a month. Thank you to all our patrons and YouTube members for the continued support. And if you're not subscribed yet to the channel, make sure you hit that subscribe button. And I'll see you all next time. Bye everyone.
Heck yeah. So I mean that's quick, but that's actually a very important thing. Like, I can tell the AI has a lot more direction towards me in, like, the prediction. Like, yeah, it's prediction, so it's trying to go around. It's like, oh, it's over here. And then it moved it up a little bit. Boom. And then it's gonna go... Oh, yeah, that's so cool. That is so cool. I love this stuff so much.